diagram of 1 centimeter to 50 centimeters, but in the triangle it says 3.6 meters. So when we were doing proportions, I don't know which one to line it up with. So
How do
should I change the 3.6 into centimeters? Right?
yes.
Okay.
Yes.
And then for question 3, it was like an accurate scale diagram. So it was given 2 angles, but oh no, for question 3. Yeah.
The accurate scale diagram represents the vertical wall TF of the building that stands on the horizontal ground. It is drawn to scale of 1 centimeter to 8 meters. Find the height. Okay. So in this case, we can solve it correctly, but we might get different answers because of the size of PDF. So find the height of the building. So what I'm going to do is, suppose I am measuring this. See, if I just zoom in or zoom out, I'm actually changing the size. But once it is printed in hard copy, that would be perfect. For example, if I measure this and let me say that this is like 6 centimeters. Okay. And then we have given that 1 centimeter is to 8 meters. So find the height. I know 1 centimeter represents 8 meter. So this 6 centimeter would represent x meters. Now when we cross multiply, we get 6 8 times is 48 meters height in reality. Yeah.
Yeah. And then yeah, everything else would be clear with that.
Yeah. Find the distance from the point A to F. So again, same way we just multiply it with 8. Then find the angle of elevation of the top T of the building from A. So that is already 35 degrees. And what about these questions? Section 2.
Um, I wasn't sent those.
Sorry?
Um, I wasn't sent those. I was only sent like the first page.
They are in the single file, one page.
I can
You can see them if you just scroll down.
see. Oh yeah, it was in the second, like when you scroll down. Because I didn't want to see the answers after that, so that's why. Because there's
Like,
the answers before that.
yeah, that's why I mentioned like section 1. So one would know that there's maybe section 2 as well. No issues. These were simple questions. Actually, these were those which could not be done like in soft form. So you could still
Genre?
practice them, and we'll continue with this exercise of sine cos tan. Okay.
Okay. Okay.
So a quick revision before we jump on to the exercise. We just did for tangent. Before we start with the book again, we'll do sine cos tan all three. Okay. Vertices are labeled with capital letters. Angles and vertices are mostly labeled with capital letters, and the sides are labeled with small letters. Let's say this is E, F, and G. Sine A, cos A, tan A. When we have sine C, cos of C, and tan of C. We do not write this for 90 degrees. Now we know the formulas were some people have curly brown hair through proper brushing. So either we say perpendicular or opposite, either we say base or adjacent. So this is the formula. So for sine A, When I'm looking at A, I know sine is perpendicular over hypotenuse. Perpendicular with respect to A is F, and hypotenuse with respect to A is G. Hypotenuse would actually never change with respect to any angle. So when I'm looking at A, I'm writing perpendicular over hypotenuse. Any issue?
No.
Now please tell me the remaining answers. Cos of A.
A was adjacent, so it's going to be E over, right? So it's F.
That's E over G. Adjacent over hypotenuse. Adjacent with respect to A is E, and
And
hypotenuse is still G.
then tan is opposite, so F over adjacent, so F over E.
That's right. Sine of C.
So opposite of C would be E, E over G,
Very good.
and then uh, G over, no, it can't be. So F over G,
Very good.
and then E over F.
That's right. Now, there is something which we will discuss at a later stage, but I just want to highlight. You see, A and this C, right?
Yes?
So, when we are talking about sine A, that is actually equal to cos of C. When they're opposite angles in the other two corners, their sine and cos is equal. You see,
Okay.
sine A is equal to
Mhm.
cos C.
Yes.
Then see, cos A is equal to sine C. And see, tan of opposite corners is actually reciprocal of each other. So if I just have a triangle and I do not know all the values, for example, this is 3 and this is 5, this is A and this is B. So if I write cos of A, that is 3 by 5, any objection?
No.
So for the opposite side, sine B, I'm going to write the same number, 3 by 5.
Yeah, because they can work both ways.
As I said earlier,
Yeah.
that we will be discussing this later. So don't just panic if number of identities are increasing. So this brings me to this identity. Cos A is actually equal to sine 90 minus A. If I just write the angles, let me say this is 30. So this is for sure 60 because complete is 180.
Mm-hmm.
This is a fixed 90. So remaining two angles are complementary. Their sum is always 90. If I write this as 40, the other one would be 50. If I write this as 45, the other one would be 45. If I write this as 1, the other one would be 89. Which brings us down to, I can say cos of 2 is equals to sine of 88. Sum of these two is always 90. That was just one single identity. We'll do this in detail. Okay, so as far as this exercise and practice is concerned, we need to be fluent in recognizing sides. So tan of z,
Where's Z? Oh, the angle. So that would be N over, what is, it doesn't have like a letter representing it.
I think the screen is loading. These are the two letters. I'll highlight them.
Yeah, but afterwards it's the, and then,
Actually, there's no hypotenuse in tan.
Opposite and adjacent. So
Yeah.
that would be Z and M. Yeah.
And
And
10y.
Y would be M over N.
That is m over
It's
n,
just
right?
reciprocal of each other. Yeah.
F part tan c.
A squared over A.
That's correct. And final answer would be
A.
right.
Yeah, just A.
D part tan d.
P fifths over P thirds. So that's just P squared.
E squared, right? Okay, when we were, if I ask you for sine or cos, definitely now we need to know hypotenuse also. So do you remember that formula? Hypotenuse square is equals to base square plus perpendicular square. So we can always find the third side if we are given with 2.
Mm-hmm. So
And
this is
in
Pythagoras,
some
right?
books,
Yeah.
in some books it is written like this. Yes, Pythagoras theorem.
Mm-hmm. Okay.
Number 3, find the length of the lettered side. In each case, give you answers to 3 significant figures. Lettered side. So x is unknown. So what would you use? Sine, cos, or tan?
I would use cos because
It
it's
is actually
adjacent to hypotenuse.
not cos, because cos is, yeah, adjacent over hypotenuse. So we can see adjacent is 3 already, but there's no hypotenuse.
Oh, so we have to, okay. So then we can also use tan.
We can use tan, yes.
Yeah.
And this exercise is coincidence. It depends on tan only because none of the hypotenuse is given. So
Oh,
tan
okay.
of 60 is equals to perpendicular over base. So x is equals to 3 tan 60. So let's use our machines and see if we get the same answer. My calculator shows me 3 square root 3 as exact form, but the question requires 3 significant figures. So I'm rounding it off to 5.20 centimeters.
Let me get an answer. You got 5.20.
Yes.
One. Okay, what? So
I
you
was
you click on the tan button. No, you click on the 3 and do you first times the 3 into 60 and then you do, or do you just do 3 tan 60, right?
it will give you same result. Either you type it like this or you type 3 into tan 60, it will give you same results.
Okay. Add.
It was 5.196. So I rounded it to 3 significant and got 5.20.
Oh, okay. I see. 5, yeah, 5.2. Okay.
B part. Tan of 30 is equals to
Is equal to y over 8.
y over 8. So y is equals
8
to,
10. Yeah, 8 plus 10 over 30.
What are you getting? 4 point?
4.6.
4.62. Keep it to 3 significant figures.
Okay, 4.62.
C part, tan of 70 is equals to z over 13. Z is equals to 13 tan 70. So what are you getting?
Sorry. 7 point, so it has to be 3 decimals, right? So 7, 5? No. Yeah, 7 point.
Make sure your calculator is in degree mode. I'm getting 35.7. And see one more thing. That angle is obtuse and it is opposite. It cannot be less than 13. Like the triangle is wide open, face is wide open. So it should be more than 13.
Okay.
Answer is 35.7. Is your calculator in degree mode?
I think so. Can just mode. Or maybe it was a misclick. I don't know.
Maybe just quickly type 13 tan 70.
Okay. Okay, no, it wasn't on degree mode. I think I just misclicked something. I don't know.
So now are we getting same answer?
Oh,
Then try D part.
okay. So it's P over 3.8. So
Yes.
it goes to 1043. So it's just 3.8, 1043.
And final answer?
Sorry.
Whatever you said is correct. So the final answer is?
I'm just getting it.
Sure.
What? Oh, it is on degrees mode. I got
Yeah.
something negative, but it's on degrees. I know it's on degrees.
Which is tan of 43 is equals to perpendicular over adjacent. So when you multiply, this becomes 3.8. Tan of 43 is equals to P. And that is 3.54.
I don't know. Three point 43. Okay. So could we do like the 3.8 after? Like after we do the 10 and then the 43?
Yes, we can do that. In that case, we'll be writing it like this in calculator into 3.8. Make use of bracket. Now that would be compulsory.
3.54, right?
Yes.
Okay.
Try for Q.
Q? What?
Yeah, E part.
Oh, okay. It's Q over, 18 equals to 1045. Okay. Times. So just 18.
That's right. Now see one more thing. This was 45 and we know this would also be 45. You see that's an isosceles triangle and it is coming out to be 18.
Mm-hmm. What sides are the same?
Last one.
1043 times 11. So 10.26. 10.26.
That's correct. 10.3. We're keeping it to 3 significant.
Oh, yes. So 10.3.
Yes. Now, the other side is actually unknown. First, all the opposite sides were unknown. Now, the adjacent sides are unknown. So, when I look at the first one, I am looking at tan 30 is equals to 12 by x. And I know x is equals to 12 by tan 30. Calculate the length in each case. In some cases, you are expected to calculate the length of the adjacent. Make sure that you carefully do when substituting lengths into the formula and nothing is expected like decimals or exact form. So I'm getting 12 square root 3. And if we have to go for decimals, that would be 20.8 centimeters for A. Sometimes the adjacent side is missing, sometimes the opposite side is missing.
Okay.
Try
So,
B. And
yes. Do I have to tell you like my steps or can I just give you the answer?
the answer.
Okay.
You'll only get correct answer when the steps are correct.
By 15. So 16.1.
Very good. Next.
35.3.
See, do you think this could be 35?
No,
This is 18. Because
definitely.
this is an acute angle, it should be less than 18. So there's something wrong in punching those buttons.
Oh, I see. Okay. So times 18, which is 9.17.
Yes. D part.
54.
Before you solve, it would be more than 10.8 or less than 10.8.
It should be less.
Very good.
So it'd be 7.84.
That's correct.
7.85 because of the 6.
Yes, 7.85 centimeters. The next one. I'm waiting for your answer.
Yes. I think I got around, so that's why I'm redoing it.
Okay.
$40.6.
That's correct.
Yeah, 40.62. No, 40.63. Yeah,
That
so
is correct.
40.6. Okay.
Yes.
And then F.
F part. Yes. Are we going to get answer less than 83.3 or more than 83.3?
More than. Oh, no. Yeah, more than, yeah. Because it's
Yes.
odd.
Yes.
83.3. So it's 114.65. Yeah, it can just be 114.
Yes.
150.
May I read
Yeah,
115? Yeah,
because of
correct.
the 6. Yep. So G.
Okay. Let's see question number 5. Use your calculator to find the value of tan 47, correct to 4 decimal places.
Okay. So it's 1.0723. 1.0724. Yeah, because of the 6.
The diagram shows the vertical tree OT whose base is O 30 meters above the horizontal, 30 meters from the from horizontally from point M. The edge of elevation of T from M is 47. Calculate the height of the tree. So if I say tan 47 is perpendicular height, or let's say OT would base.
32.2.
32.2 meters, correct. Malik wants to estimate the width of the river, which is parallel banks. He starts at point A on one bank directly opposite a tree on the other bank. He walks 80 meters along the bank to point B and then looks back at the tree. He finds that the line between B and the tree makes an angle of 22 degrees with the bank. Calculate the width of the river.
Oh, so the height basically. So, okay. So, oh, yeah, that doesn't seem right. 10, 22, okay.
What are you using? 1022 is equals to?
Yeah, 1022 equals to 0.404, basically in short form. So then afterwards, divide that by
Basically, 1022 is equals to width divided by 80.
32.32.
Correct.
Yeah.
32.32 or 32.3 and meters. Number 7. The right angled triangle ABC has BAC is equals to 30 degrees, taking the length of BC to be 1 unit. Work out the length of AC. If this is 1, so we can calculate AC.
Oh. 1.732.
Exact form. Calculator leaves your answer in exact form.
Exact form
Like this.
of 3 squared.
Yeah. Square root 3.
Mine didn't do that. So I only got like the decimal version.
Whenever you get time, you should have the one which leaves your answer in exact form. How to check it is, suppose we type 10 of 30. So I'm getting square root 3 by 3. So if I type 10 of 60, I'm getting square root 3. 10 of 60 is square root 3, yes. And in other ways, if you just type square root 3 in your calculator scheme, you will have answer as square root 3. So you should have exact answers because calculator is allowed in exam. And for such questions, we can use these exact values.
Okay, I'll ask my brother about it because this is his like normal calculator. Maybe when he was using it, he I don't know changed something about it. So I'll
Yeah,
just ask.
we call it like scientific calculator.
Yeah, it is scientific calculator, but I don't know.
It should display.
Yeah, I'll just ask him about it after class.
B part is use Pythagoras theorem to obtain the length of AB. Now see, if you're getting in decimals, this would be tough. But
Yeah.
without decimals, we know that hypotenuse square is equals to adjacent square plus opposite square.
So just 3 plus 1. So 4 squared, so it's 2. Yeah, no, 4. No, yeah, 16. No,
2.
square root 4, sorry. So it's just going to be 2.
Basically, these are word problems, but Directly, there's small questions. So the diagram shows a ladder that leans against a brick wall. If the angle between the ladder and the floor is 82 degrees, the ladder reaches 3.2 meters up the wall, and the distance d meters of the foot of the ladder from the bottom of the wall. Give your answer to the nearest centimeters. So it is our choice. We change it in centimeters directly, or we convert it after the final answer. I think changing first would be much better. Tan of 82 is opposite over base. So d is equals to 320 over tan of 82. So now this will give me answer in centimeters directly.
T 40 44.997.
Yes. So to the nearest centimeter
So just
is
45.
45. Try number 9.
Um, 4.6. So 4 meters tall. So no, he was wrong
So
because the
maybe
answer is 4.65 meters. So it would just be 5 meters basically. So he was wrong.
correct. So if we use Pythagoras theorem, this would be 4.5 and this would be 1.2. And then we can find this height. Let's label that x. So x is equals to 4.5 square minus 1.2 squared whole square root. And I'm getting 4.33704, approximately equal to 4.3 meters.
So he is correct. Or
Yeah, he's wrong because that's like 30% more, 10% more.
okay.
Now, calculating angles, as we discussed earlier, that in case of angles, we'll be taking inverse. For example, we have tan theta is equals to unknown angle is equals to 3 by 4. So theta would be tan inverse of 3 by 4. This is known as inverse when you take the ratio on the other side. If you can see tan, you will see an inverse on top of it, which can be used by pressing the button shift.
Shift. Can you show me where shift is on your calculator?
Yeah, in mind that this is right at the top. And in this line, this is sine cos 10. My finger is next to 10 and right hand side is right next to shift. So if I press this, you'll see tan. If I press shift and then that button, you'll see tan inverse. That is tan raised to a minus 1.
At my very top, I have just basically y equals to window, zoom, trace, graph. And then above my tan, I have vars. Oh yeah, that is tan inverse. Okay, I see it.
Yeah. So now we need to find A. If we go for tan or cos or sine, we can always find A because all three sides are given. We will have a very slight difference in sine cos tan. If I just say this is tan A, I'll be writing 3 by 4. And A would be tan inverse of 3 by 4. I'm writing all three first, then we'll write the answers. If I go for sine of A, I'll be writing opposite over hypotenuse. So A is equals to sine inverse of 3 by 5. And then if I write cos, this is cos of A is base over hypotenuse. So A is equals to cos inverse 4 by 5. Now I'm using calculator.
For each one, right?
Yeah, for each one. And the first one is giving me 36.8698 and shift sine 3 by 5 is giving me 36.8698. They are giving me exact same answers. Shift cos
Yeah.
4 by 5 is 36.8698. So whenever we solve angles, we write them to one decimal place. So this is 36.9 degrees for each of it. Clear?
Yes.
Now find B, ball.
Which one do I choose? All of them?
Any one.
Okay. So I used the tan inverse and I got 42.7. Yeah, 42.7.
42.7.
Because I did 12 over 13.
I'm getting 67.4.
Okay, I'll redo that.
You use 10.
Yeah, I used tan.
So tan of B is 12 by 5.
I see. So 12 by 5. So yeah, 67 point. Yeah, 67.4.
Yeah. Now try to find this C using sine theta.
Okay. So,
And what ratios are you using?
24 over 25.
Correct.
Twenty-four, 25.
So what are you getting? Final answer?
Um, It's glitching or something. What?
Sine inverse. If it is doing that, just reset.
Okay.
Whenever you clear it, you get rid of garbage values.
Okay.
You should get 73.7.
74, 25. Is this going to be? Oh, so you got 73.739, right?
Yes.
So just 73.7.
Yeah, up to 1 decimal place. Angles are up to 1 decimal place in degrees. Now, what is the value of C?
See?
Yeah.
So it's 73.7, right?
Sorry. D. D. Yeah, that's right. C is done. D.
Okay. So do you also want me to use sine for this one?
Anything.
Okay. It's 7/25 I'm gonna do. So 7. I got 16.2. Yeah, 16.3.
16.3. And what did you use?
I use sine.
I use sine. May I show you a simpler way?
Sure.
D is equals to 180 minus 73.7 minus 90.
Oh, yeah.
So
But
what
it's
happens is the
also
creep.
extra practice, so that's good. But
Yeah,
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 that's easier.
yeah, sure. But do keep that in mind whenever we are solving such kind of question in exam. Our mind is actually overwhelmed with the concept that we are doing trigonometry and we are using those ratios. And sometimes we just skip that out of mind that there is a simpler way.
Okay. Always a
So
simpler math.
whenever I go through any question, now see it says calculate correct to 1 decimal places, but these questions after question number 3, um, see this question number 3, it says 3 significant figures, but in question 4, there's nothing given. Calculate the letter in each. Some cases expect to so, and no significant figures, no decimals, nothing given. So there's a relaxation.
So this.
Marks won't be deducted. In these cases, which instructions do we follow? They are always given on the first page of question paper. That in case we are not given the degree of accuracy, we will answer up to this much. Okay.
Okay.
Find correct to 1 decimal place the acute angle that has the tangent ratio. Now this is important. Acute angle. Now we're going to type this 10.85.
And
Sorry,
point.
sorry. This is like angle is unknown. This is the ratio. So basically tan theta is equals to all these ratios are given. So theta would be tan inverse of whatever is given.
Oh, 0.85. I see. Okay.
So I'm getting 40.4 for the first one.
And I'm, yeah, 40.4 because it's 40.36. So yeah, 40.4. And then for B, right?
50.99. So that would be 51.
And then C,
See, 1 decimal place.
3.56. So for C, I got 74.3.
Correct.
And then D, just 10. So that is 84.23. 84.3.
Correct. Number 2 says find correct to nearest degree the acute angle. That is one and the same thing. Let's look at number 3. Find correct to one decimal places the angles.
Oh, okay. A opposite 7, 10, 10 inverse. 34, 35.
Correct. So A is equals to 35.0. One decimal place. B part.
Nine over to 77. Yeah, there's 77.
77.5.
Oh, yeah, 7 because we have to be one decimal place. 77.5. And then C.
Yeah.
So I do one for D and then one for C. Okay. Wait, yeah, it's not isosceles. D equals to 5 over 4 inverse 4. So D equals to 51.3.
51.3.
And then C equals to 38.7.
30.7. Correct. Try this fourth part. Lettuce stands on the horizontal ground and leans against a vertical wall. The foot of the ladder is 2.8 meters from the base of the wall, and the ladder reaches 8.5 meters of the wall. Calculate the angle the ladder makes with the ground.
Oh, I see.
What are you going to use? Sine, cos, or tan?
I'm going to use 10.
Okay.
8.5 over 2.8. 71.8.
Correct. Number 5. The top of a vertical cliff is 68 meters above sea level. The ship, a ship is 175 meters from the foot of the cliff. Calculate the angle of elevation of the top of the cliff from the ship. Angle of elevation of the top of the cliff from the ship. So basically this angle.
So opposite. I'm going to also use 10
Correct.
and 175. Okay. 68 over 21.2.
21 point. Correct. O is the center of the circle with OM is equals to 12. Calculate AM and AB.
Um, 10 42 equals to 12 over x. So I see. Divided by, so 13.3.
Correct. AM is 13.3. And what would be AB?
The same. Oh, completely. So
Yeah,
13, yeah, 6, so 26.6.
26.6. This is also a property of circle that whenever we have a chord and there's a line perpendicular to it, it actually divides it into equal half. We'll
Okay.
be doing this in circles. A right angled triangle ABC has hypotenuse AC is equals to 7 and the side BC is equals to 3. So let's say this is that right angle triangle and AC is 7 and BC is 3 centimeters. Calculate the length AB and hence angle ACB. Angle C is unknown and AB side is unknown.
I can do cosine adjacent, so 3/7 inverse.
Correct.
What? Oh, what's going on? Okay.
So are you getting 64.6?
Uh, I think a small error. Okay. I'm gonna reset my calculator. Try again.
Okay.
I don't know why, but the inverse cosine button is not really working. Like when I click it.
Okay. It is 64.6.
Okay.
And now go for X. How will you find that?
For X, I can do the angle again, and I can do 10, and it can be,
Okay.
but
So
no, because I don't have the angle either.
you have the angle.
I have one of the angles, so
Yeah. So,
it's
so
gonna be
you,
X over 3. So it's just basically tan 64.6 times, yeah,
that
times 3. Yeah, times 3. So 64.6.
that is one thing. Tan was one thing. We can also use sine for X.
Do you want me to use sine?
Yeah, sine theta. Sine theta is opposite over hypotenuse. We can also use that.
Mm-hmm.
In this case, remember that whenever you have two sides, hypotenuse Pythagoras theorem is the simplest case.
Okay.
See,
Yep.
7 squared is equal to x squared plus 3 squared. There are two things in this. One, we avoid using sine cos tan and inverse. Second, we can get this in exact form. So 7 squared is 49 minus 3 square is 9, that is 40. So x square is equals to 40, x is equals to square root 40. You also get the exact form. And if you want to convert, this is 6.32.
So for an exam, could we leave it as square root 40?
Yes, unless until the question requires.
Okay.
If this question would have said 3 significant, then that's a compulsion that we have to write 6.32 centimeters. If there's nothing required in the question, that's your choice.
Okay.
Now, this was a mix of sine cos tan, but most of the time that was tan. So, in the same way, exercise is now proceeding towards sine and cosine ratios, where sine ratio is opposite over hypotenuse and cos ratio is adjacent over hypotenuse, exactly in the same manner as we solved for tan. So find the length of the sides. So if I just look at the first one, now I know that we cannot use tan because adjacent side is not given and hypotenuse is there. So with respect to 55, opposite is given. So sine of 55 is equals to opposite over hypotenuse. X is equals to 11 sine 55. And I'm getting 9.01 centimeters. Try B part.
B part is equal to again. So we're given the opposite, and we're also given the adjacent. So I can also use tan for this. Oh.
No,
Oh.
opposite is actually missing.
Oh yeah, opposite is missing, so I can't use tan for this. So I can, there's hypotenuse and adjacent. So I can use cosine.
Correct.
But I already saw the answer.
No, but you're going through that working. You're not
Okay.
sitting in exam. I actually punched it because we're getting a technical fault with the calculator.
Yeah. So yeah, cosine. So I can't really do that one. Wait, let me try it again. So clear cosine. And then yeah. No, it doesn't work for me, so I can't do cosine. But I
Oh,
can do sine and tangent.
okay, right. Okay, got it. So try C part.
Adjacent and opposite. So I can do tangent for this one. So h over 35.2, 1050. So 1050 times 35.2. 35. No. So 41.9.
Correct. Okay, what do we use to find X?
And hypotenuse. So we can use sine.
Correct. Sine X is 8 by 12. X is equal to sine inverse. Either you write 8 by 12 or simplified form, one and the same thing. And for Y,
For y, we can use, we have adjacent and we have hypotenuse. So we can use cosine.
that's right. Now see if our button is not working. I'll actually solve for this Z.
Okay.
That is sine of Z is equals to 31.4 divided by 63.2 is equals to sine inverse 31.4 by 63.2.
Okay.
Shift sine 31.4 divided by 63.2 is 29.8. Now I can solve that. Obviously, in exam, we won't do this.
I'll get a
We
virtual calculator for the exam so that I won't have to deal
Yeah,
with like doing another thing. 63.
yes, save time is important. So I'm getting 60.2 for y. Okay. In case anything happens to the calculator, we should know our way out. Obviously,
What
not
if the
always.
button doesn't like a really important button during the calculator? Is there like, can we go and tell somebody?
Yes,
Okay.
during the exam, that's your right. They do have spare calculators sometimes.
Yeah. Yeah. And
That's
it's gonna
and
happen in our school, right? It's happened in school. So
yeah, they're very facilitating. They
yeah.
can always like announce if someone is having a spare one. They'll share it.
Yeah.
Okay, so now the questions keep rotating around sine cos tan. A ladder 4.8 meters long leans against a vertical wall with its foot on horizontal ground. The ladder makes an angle of 70 degrees with the ground. How far up does the ladder reach?
We have the hypotenuse. So we can do sine for this.
Very good.
So sine 70 equals to uh, 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 unknown over 4.8.
Correct.
So just be sine 70 times 4.8. So sine 4.5. Yeah, 4.5.
So how far is the foot of the ladder from the wall? Use Pythagoras theorem.
Mm-hmm. 3.3401. Yes. 1.64.
Correct.
Yeah.
Okay. Okay. Okay, I'll share this exercise for practice. And let us both see if there's any question which needs to be addressed for each of the following. Write down sine cos tan. Use your calculator to find. We do understand that we have a limitation for cos. And the third one, angles, sides. We're going to find the missing sides. Or calculator to find one decimal places. Acute, acute, acute. Okay. Okay. I'll share all of this,
Okay.
and this is like one complete exercise, and then there are answers.
Okay.
Won't have any confusion in this.
Yep.
Anything you'd like to ask?
Um. No, nothing.
See you in next class, inshallah. I'm expecting that you will get all these correct. Did you get time to solve?
Yes.
Any confusion? Any wrong answers?
I wasn't. No, my answers were correct. I just didn't do question 6F
Okay.
because I didn't understand it.
X would just cancel out.
Sorry.
Find X would just cancel out. Find to one decimal place the lettered angle in each of the following angles. So when I'm looking at F, this is the opposite side and this is the hypotenuse. So opposite and hypotenuse is sine.
Mm-hmm.
Sine of F is opposite over hypotenuse. So X just cancels out. So sine F is equals to 3 by 15 or 1 by 5. F is equals to sine inverse of 1 by 5.
Oh, okay. Okay.
Anything else?
Mm. Nothing else on the worksheet. No.
Okay. For each of the following angles, calculate tan x, sin x over cos x. Okay, this is just like calculate. We just plug this in and solve for them. So, and it is also teaching you that this is actually the identity. Tan x is equals to sin x over cos x. So, for example, if I talk about 30, plug this in. This is tan of 30. On the opposite side, it says solve for sin 30 divided by cos 30.
So it'd be 10/30.
Yeah, so tan 30 is square root 3 by 3. So when you punch this whole thing in the calculator, you get square root 3 by 3. Even if you get it in decimals, you will get the same answer.
Okay.
Then sine square 30 plus cos square 30. This is another identity. One is, let me write that here. One of the identity is tan theta is equals to sine theta over cos theta. Second identity is sine square theta plus cos square theta is equals to. The only thing to consider is that these angles should be same. Either we write it like this or we write it like this. It is exactly the same thing. So this is sine 30 whole square plus cos 30 whole square. Basically the angle is same. So you'll get answer as 1. Choose another angle and repeat the calculation. So we choose any angle. Let's say sine 10 squared plus cos 10 squared. We'll again get 1. Question number 14. Exam style question. The diagram shows right angle isosceles, shows a right angled isosceles triangle and an equilateral triangle. On the left hand side, we have a right angle. On right hand side, we have isosceles. And we have equilateral triangle. Write down the value of angle ACB. So when we look at ACB, that is angle X. Looking at X, I am
Like tan inverse
very,
1/1, right? Okay.
that's right. So X is equals to tan inverse 1 by 1, which makes it 45 degrees. That was one thing. And just see, when we already know that these are isosceles. So if this is 1, and this is 1, this is X, I can also write X over here because it is isosceles. So 2X plus 90 is equals to 180 is other way to find X.
Hmm.
Either we go through trigonometry or simple algebraic addition. E part says use Pythagoras theorem to calculate the length of AC, leaving your answer in exact form. So AC squared is equals to 1 squared plus 1 square. Hypotenuse square is equals to base square plus perpendicular square. So AC squared is equals to 2. AC is equals to square root 2. Copy the triangle ABC. Include your answers to A and B. Done. Use your diagram to find the exact value of sine 45, cos 45, and tan 45. So when I'm looking at the diagram, sine 45, any one of those, sine is perpendicular over hypotenuse, so that is 1 by square root 2. Cos 45 is again 1 by square root 2. Tan 45 is 1. Write down the value of angle y. Now we are looking at the second triangle. Can you figure that out?
Mhm.
Angle y.
Oh, I can't do this one though.
You can do it.
No,
You
no,
all
no.
so much.
No, for this one, because this one is cos.
So, oh, okay.
Yeah.
Because of buttons. Okay, just guide me through it. I'll use my calculator. So you're selecting cos y is equals to what?
Cos y is equal to 2/1.
1 over 2.
Oh, 1/2.
Base over hypotenuse. So
Yep.
basically, we are splitting this in half, and then we can use the left half. So this is 1 base over hypotenuse. Cos inverse 0.5. It gives me 60 degrees.
Okay.
So y is equals to 60 degree. Write down the value of angle z. What are you using?
I have hypotenuse.
Hypotenuse
We
and
also have adjacent, so that can be cos, but since I can't do cos, so we also have hypotenuse and we also have opposite. So it can be sine as well.
That's right. And we do have two angles already.
Yeah, so we can just figure it out. Okay, so 60 and 90. Okay,
So we're left with
it's 30.
30. Now use Pythagoras theorem to find EG.
Okay,
Can you do that?
yes. So square root 5.
That is square root 3.
Sorry? C?
Square root 3, 3, square root 3.
Oh, yes. 4 minus 1. So square
Yeah.
root 3.
This is square root 3, this is 60, this is 30, so on. So EG is square root 3. Copy the diagram, include answers thesis. Use your diagram to find the exact value of sine, cos, tan 30s and sine, cos, tan 60. So diagram already copied. Sine, cos, tan, and sine, cos, tan for 60. Okay, using the diagram without calculator, this is how we can do it. We can like memorize this diagram as well. And the other one was with 45-degree angle. So this was 90, 45, 45, 1, 1, and square root 2. So we can memorize these two. So sine 30 is 1 by 2. What is cos 30?
Cos 30 would be 3, oh no, square root 3 by 2.
Correct. Tan 30.
Tan 30 is 1 over square root 3.
Correct. Sine 60.
Sine, that would be square root 3 over 2.
Cos 60.
Cos 60 would be 1 over 2.
Tan 60.
And then tan 60 would be square root 3 over 1.
Square root 3 over 1. We also discussed this earlier that cos 30 is equals to sine 60
Yes.
and sine 30 is equals to cos 60, which brings us down to another identity. Summing that up, first was tan theta is equals to sine theta over cos theta. Second was sine square theta plus cos square theta is equals to 1. And now this, notice that the sum of these two angles is 90. So it would bring us to cos theta is equals to sine 90 minus theta.
For them to be equal.
Yeah, they are always equal.
No matter if it's 90, like, if it's supplementary or not.
They will be complementary. The sum is always 90.
Oh, sorry. So no matter if it's complementary or not, it's
No,
still going
no,
to be.
it should be complementary. The identity
Okay,
is
yeah.
because you're actually taking out that angle from 90.
Okay, so for them to be equal, it's just going to have to equal to 90 degrees.
Yes. For
Okay.
example, if I say this is cos 10, the other one would be sine 80. If this is sine 1, the other would be cos 89. The sum has to be 90. See these two angles? If I just add them, theta plus 90 minus theta. So when you add them, you're left with 90.
Okay.
They're always complementary. Okay. Copy and complete the table below using your answers from previous part to this question. So we're just filling this up. We already have those values. So we already have these values. Sine 30 is 1 by 2. Sine 60 is square root 3 by 2. Sine 45 is 1 by square root 2. For this, I'm using the second triangle. Sine 45 is 1 by square root 2. And cos 45 is 1 by square root 2. And tan 45 is 1 by 1, which is 1. Cos of 30 is square root 3 by 2. Cos of 60 is 1 by 2. Tan of 30 is 1 by square root 3. When calculator simplifies, it does this. Both are equal, basically rationalizing the denominator. And tan of 60 is square root 3 alone. Now we'll have such questions where we would be required to draw any line if we require to get a desired right angled triangle in order to apply sine cos tan. Solving problems using trigonometry and like their applications. For example, you are in a boat and you see someone standing at the cliff, or this is the cliff and you want to find the height of the cliff. So you know that you are 50 meters away and you have to look up at 70 degrees. So we can find this height using tan of 70 is equals to height over 50 perpendicular over base. So height would be 50 tan 70. So basically we're just going to add up some stories to it. Other than that, it remains a simple calculation. So 50 10 70 is 137. So this is 137 meters high.
Okay.
Calculating distances and showing a small note that shortest distance is always perpendicular. For example, I have this line at the ends we mark A and B, and I'm standing at this position. So distance from A is obviously more than distance from Z. Do you agree? From C.
Yes.
And towards this line, if I just keep on moving, when I will make exact perpendicular, let me call that Q, this would be the shortest distance, and again it starts increasing. So the shortest distance towards anything is perpendicular.
So will this be asked in an exam? So if it's asking us to find like shortest distance,
Yeah, they would
might be
either
a question.
yeah, that would be a question. They would either say find the shortest distance, or they would mention that find the perpendicular distance, or the wording would be find the distance of the point from the line. Just imagine wherever you're sitting, you have a wall in front of you, and
Mhm.
there are two ends of that wall, and you can pretty much imagine which one is closer and which one is further. But you would see that if you have to reach that wall in least possible time, both of these points are not the one you'll choose. If you just have to touch the wall, you'll rush perpendicular towards the wall. That would be the closest.
So if it asks us to find like the perpendicular line, we'd have to use like a calculator for that, right? I mean, protractor for that, right? So that's
Mostly 99.9% of the time, these would be calculations, no drawings.
okay. So even if it asks us to find like a certain line, do you think there will be like any questions where they ask us to find what angle something is, like without any trigonometry involved?
Yeah, there are two type of questions. One is a scale drawing. That
Yes.
is very easy, and that would be a mix of like you remember we did construction of triangles and
Yeah.
quadrilaterals. So in case of trigonometry, it would be just like 5 to 10% of that. So yes, they may ask you that measure the angle. So we use our protector.
Okay.
For example, we'll move to the exercise shortly. Let me just explain this with an example question. For example, we are in a park and it passes through point A and point B and point C. So these are tracks, and definitely some data would be given. It may be lengths, it may be angles. For example, let me say this is 110 meters, this is 70 meters, and this is 60 meters. Mm, this is 85 meters. Now the question may be that a helicopter, we are in a park which has these three paths, and one helicopter comes by and is flying over the track. It flies over AB. So this is its path, flies over AB at a height of let's say 200 meters. And it would say that someone is standing at C, find the greatest angle of elevation. Find the greatest angle of elevation. Now, the only difference between this question and whatever we were doing, for example, I just give you the same question again, and I tell you the height is 137 meters, and this is 50 meters away. This is the cliff, and this is your boat, and I ask you to find the angle of elevation, unknown angle. So, what would you do? You just use simple trigonometry. In this case, you actually have to decide where it would be for it to have greatest angle of elevation, and then we will use certain values.
So
So
greatest
now
could
just
be.
imagine
Mm-hmm.
wherever you're sitting, the wall in front of you, and top two corners, one on left and one on right. Now, whenever you have to look at that corner, you would have to raise your chin, right?
Mm-hmm.
Now, according to me, where I'm sitting, the right hand corner is actually closer to me and left one is further away because I'm sitting next to the wall, which is to my right hand side.
Mm-hmm.
Now, whenever you're looking at those two corners, if you just run your eye through one corner to the next, one corner to the next, would you notice that when it is further away, we can actually lower our chin?
Yes.
So, our chin is at the highest point when we are looking at the closest point.
Mm. So that would be so for the person that would be perpendicular still. Oh no, but they can't look at.
Yes, exactly. Now, someone's sitting on this chair,
Mm-hmm.
and another person walks towards the child. Now, they're making an eye contact. You see, when he comes closer, angle of elevation actually increases.
Yes.
So the closest point gives you the maximum angle of elevation, and the closest point is the perpendicular distance. So this would be my distance, one thing. I'm naming it as x, and we already know the height is 200. If I just try to extract this height as 200, and this horizontal distance x as unknown. So this would be my angle which I need to find. Now, definitely, when this question, they will place this question, we will have few values. For example, let me say this angle is known. So we'll be able to find x. And then in this second part, we'll be able to find this angle of elevation. So this is how trigonometry
Well,
would be
when
used.
we do write which one is the greatest, the working is showing like the actual answer, right? It's not just like we draw it and then try to explain that.
No, 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 nothing.
As-
That's right. That's right. Only the calculation. But that is also true that if we are able to sketch for ourselves, if the
uh,
diagram is good enough, it is very easy to understand. But for examiner, that's not an issue. We can do it without diagram as well. Diagram is not part of solution or compulsory.
okay.
Okay. So calculating distances. Now see, the diagram shows an isosceles trapezium ABCD. Trapezium is one thing, four-sided figure with one pair of parallel sides. But when this word is used, we know that we have two equal sides. Always, when this word is used, isosceles trapezium. Calculate the area of the trapezium. Now we know area of trapezium is 1 over 2 side 1 plus side 2 times height. Area is 1 by 2 sum of parallel sides into height. Now if you can see, I have 8.2, but I do not have AC and I do not have the height. So in order to find this height, now see, I've drawn this green line somewhere here. Our mind might be struggling, but if I would have drawn it right here, it would be very easy to think and interpret how I'm going to find this blue line. So good diagram and positioning matters. I'm going to use 4.6, 60 and height along with sine theta. So sine 60 is equals to perpendicular over hypotenuse. So the height is 4.6 times sine 60. Gives me 3.984.
Yeah.
Are we good?
Yes.
Okay. Now for AC, see this split? If I just find this horizontal part, I'll be able to subtract that from 8.2 two times and I can get AC. So cos 60 is equals to, let me name it x over 4.6. So 4.6 times cos 60 is 2.3. So x is equals to 2.3, and as we know it is same on both sides, we don't have to recalculate. So AC is equals to 8.2 complete minus 2.3 minus 2.3. And I'm getting 3.6.
And that's
3.6.
the top part. Yep.
So now 1 by 2 sum of parallel sides, that is 8.2 plus 3.6, and the height, which is 3.984, and the remaining is just the simplification. So it is 23.5 centimeter square.
Okay.
The span between the towers of Tower Bridge in London is 76 meters. When the arms of the bridge raise to an angle of 35, how wide is the gap between their ends? Try
This
that.
is also an isosceles question, basically.
Uh, Sorry?
So this is also basically an isosceles question.
Exactly, yes. When he's asking how wide is the gap, basically he is asking you for this AC part.
Yeah. But we don't have any values that's like other than 76 as for one of the sides.
We have one, two, three values.
So we have the 76 meters at the very end. We have
Yes.
35 for both ends, like of the isosceles triangle.
Yes.
And then the third one,
Whenever you think something is missing, no, remember these two things. Number one, let us assume the question is incorrect. So what would happen? It would either be discarded or either we will get full marks in final exam. Secondly, that is very less chance because it goes through a very intensive process. There's no one examiner who's making that exam. One does, the second approves it, the third approves it, it is being solved, and so on. So the tip is read the question. When you'll keep on reading it, you'll eventually pick that up that this is the data I need.
okay. I know they read their questions a lot though. I'm just confused on how to do it. But I'll
No
do
issues.
it.
That's the point. When you'll reread, actually your mind is pushing you towards those solutions.
Yeah. Okay.
So you'll get it. Just focus few seconds and do one more thing. This makes a trapezium, and you yourself mentioned that it is isosceles trapezium. Just draw the trapezium and fill in the maximum values you know.
Okay. Is it 38? Because when they're like the bridge starts
Exactly.
like close. Okay.
Exactly. So this full was 76, which actually divides in two halves, equal halves, making it 38. 38. This is the unknown side, and you know the angles.
Yeah. Okay. Okay, so it's 62.3.
The gap?
Yep.
I think I'm getting a different answer. I'm getting a very small answer, which is 13.7. Let's discuss.
Yep. Okay.
I need these two to be removed, right?
Yep.
Now this is, let's say x, I'm using cos. Cos of 35 is equals to base over hypotenuse. So x is equals to 38 cos of 35. And we know this is same on both sides. So when the full length is 76, I'm removing this two times. Two times 38 cos 35. And I'm getting 13.7. What did you do?
So basically, yeah, because I couldn't do cos at first, so I first did it through sine and tan, and then for each side I got 31.1, but I base, yeah, 31.1, so that's 62.2. So I just have to subtract that from 76. So and then that
If
will,
you used sine to find the perpendicular part,
yeah, because I couldn't do cos, so instead of like first we had hypotenuse.
so if you're doing that, I'm
Yeah.
getting 21.8. The height
Yes.
is 21.8. And then how did you figure this out?
I
The
just
x.
did tan, so opposite, and then A equals adjacent.
Okay.
Yeah.
So this is tan 35 equals 21.8 over x. So x is equals to 21.8 by tan 35. 21.8 divided by tan 35. I'm getting 31.1.
Yeah, 31.1.
Now we remove this two times. 76 minus 31.1 into 2.
Yep. So
So 13.8.
2.2, and then
We're getting same answer. Why did I hear a different one?
I think I didn't add like 31 maybe twice. I think I just subtracted it from 76. That's why I got such like a high answer.
Maybe.
I
Then
think that's
we're getting
why.
in that case, we had 44.9. Now, careful with this machine, okay?
Mm-hmm.
Sometimes we just think we just pressed the right button, but we are wrong in the wrong place.
So it,
Meanwhile, we punch, also have an eye on the screen.
so for the answer, it can either be like it's both going to be correct if we write it on the exam, 13.7 or 13.8, right? It
Yeah,
doesn't
both
matter if it's like one difference.
both will be acceptable. Some like I just forgot what my exact answer was, but the marking scheme would somehow look like this. For example, 7 1 to 13.8 3 something. So they do have that gap because they would know that this is through steps, and all of the students would round off to the exact same point.
Okay.
Exercise applying our skills. The diagram represents a ramp AB for a lifeboat. AC is vertical and CB is horizontal. Calculate the size of angle ABC to one decimal place.
So is it 16.2? Yeah, 16.2.
Yes, 16.2. So calculate the length of BC correct to three significant figures. Which method are you using?
Pythagoras.
Very good.
So 17.9, right?
Yes. Okay. Number 2. AB is a chord of circle. Center O. Radius is 8 centimeters. Angle AOB is 120. Calculate the length of AB. Now, this is something where we would improvise. Either we draw some lines.
Was it 13.9?
Quickly checking it. Yes. 13.9 centimeters is correct. Question number 3. The diagram represents a tent in shape of triangular prism. The front of the tent, ABD, is isosceles with AB is equal to AD. The width BD is 1.8 and the supporting pole AC is perpendicular to BD and 1.5 meters high. The tent is 3 meters long. Calculate the angle between AB and BD. AB, BD. So I'm using this 0.9 and 1.5. This 0.9 and height 1.5.
Okay. Tan inverse, basically.
Yes.
So it's 59.
59. B part says the length of AB.
Okay. So it's just Pythagoras then.
That's right.
$1.7.
Correct. C part says the capacity inside the tent. Can you make the formula for this to find the volume?
Prism, so 1/2 height. So it's just the bottom area, so it'd be 3 and 1.8 as well, times the height.
This is the answer. Try it.
Okay. 3 times 1.8. And then times 1.5. Yeah, 4.05, right? So what I
For
did was basically 3 times 1.8, and then I divided it by 2, and then times it by 1.5. So 4.05.
somehow you got it right, but the approach should be cross-sectional area. This is the cross-sectional area,
Mm-hmm.
and distance between these two is 3. So basically, volume is area of cross-section into height. When the shape of cross-section is a triangle, which is 1 by 2 into base into height, and then overall distance between these two. Either you use height or you use length. 4.05 meter cube.
Okay.
Remember when we discussed a cylinder? So volume of cylinder is this cross section area, which is circle pi r square, and distance between these two circles is the height of the cylinder, pi r square h.
I did the cross-sectional area of the base,
Now,
but then afterwards, yeah, but it's supposed to be the triangles.
cross sectional area stays the same throughout. So if you are looking at the base, that is a rectangle, and when you'll move up towards A, the rectangle is reducing in size. So cross section area stays same.
Okay.
For example, a burning candle, it is a cone at the top, but when it burns off, then it is a cylinder throughout. Number 4. Calculate the angles of an isosceles triangle that has sides of 9, 9, and 14. I'll do this with you. This is 7, 7.
Mm-hmm.
I'm going to use 7 and 9 with cos. Cos of b is equals to 7 by 9. B is equals to cos inverse 7 by 9. It is giving me 38.9. To one decimal place, 38.9. Now let us fill this up. This is 38.9. This is 38.9. And now we use simple algebra. Find the angle at the top. Let's say BAN is equals to 180 minus 90 minus 38.9. 51.1 degrees. Number 5. This sketch represents a field of PQRS on level ground. The sides PQ and SR run due east. That means they're parallel. Both are running towards east, so they are parallel. Write down the bearing of S from P. G, your answer. Bearing had two rules, clockwise and 3 digits.
So 250?
Bearing of
Yeah, because
S from P. From P. We're sitting at P and we're
oh,
looking at
I
S.
see. Okay, so it's just what's left. So it's 20.
Yes. So we're going to write 0 to 0 degrees.
Okay.
B part. Calculate the perpendicular. Now he's telling you the shortest. In exam, we won't have this word. Calculate the perpendicular distance between SR and PQ. So SR and PQ, the shortest distance is definitely not this. It is definitely not this. It is the perpendicular distance.
So that would mean. So as in distance, does it mean like the height, or does it mean like the
Yes.
height?
You may call it anything. Perpendicular distance, this is the one which we marked in the green line. So we may call it length or height or anything. Length would be better because he's just said that it is on level ground.
So 282. I got the
282 exactly, yes. 282 meters. Last part, calculate the square meters, the area of the field.
okay. So this is also a trapezium. So it's the same formula. 282. 98,700.
98,700, yes. In the isosceles triangle, DEF, E is equals to F is equals to 35, and side EF is 10. Calculate the perpendicular shortest. This is from D to EF.
So perfectly rounded up. $3.5.
3.5, yes. I did it using 10.
Yeah, me too.
So this is 3.50 meters. Calculate the length of side DE.
6.1.
6.1, yes. Find the length of the diagonal QT of the regular pentagon that has side of 10. Give your answer to the nearest whole number. This is exactly of same nature. Let's move on to question number 8. The diagram shows regular pentagon with side 2 centimeters. O is the center of the pentagon. Find angle AOE. Remember polygons?
Yes, the angles as well. $160 for A. 162.
AOE is 72.
Okay, let me retry that.
Yeah, see AOE. If I just draw these lines, then you might see that this is actually 1/5 of one complete circle.
Oh, so 360 divided by 5.
360 by 5,
Okay,
72.
yeah, 72. And
So
then B?
AOM,
Sorry?
second part AOM.
Yep.
AOM is half of that. And how do I know I have to divide it with 2? This 90 is giving me that surety. It is coming right in between, dividing it into equal halves. That's 36 each. C part says use trigonometry on triangle AOM to find the length OM.
Oh, oh, that's 2, 2, 4 plus 4 equals square root. That's 2, 3 squared,
How much are you getting?
square root 3.
Square root 3, getting 1.38.
So is that what root 3 is? Or
AE is 2, so AM would be 1.
yeah.
Right? Because
Yes.
this is regular pentagon. Now for OM, I'm using tan. Tan of 36 is 1 over OM. So OM is equals to 1 divided by tan, 36.
Your answer was 1.7 1.732.
1.38.
Okay. Because I was trying to do Pythagoras, but
We actually can't do that.
because we don't know the other side. Yeah, okay. So 10, right?
Yeah.
And then we solve it. Okay.
So this is 1.38. Find the area of triangle AOM.
36. Didn't we
Area.
already do that? Yeah, 36.
No.
Oh, area. See.
Anya.
0.69.
That's correct. Find the area of the pentagon.
Six point nine.
That's correct. We have these such 10 triangles. So 0.69 into 10 and you get 6.1 centimeter square. Using a similar method to that described in question number 8, find the area of the regular octagon with side 4 centimeter. So when we are considering an octagon, it has 8 sides and consider that it is equal. So this is, let me just open that up, more writing space. So 8 sides, center, and one of the side is 4. Now when it is octagon, I know we can divide it with 8. So 360 by 8 is giving me 45. All this 360 divided by 8 is 45. So the angle at the center is 45. When I split it into 2, this is 22.5. Taking the triangle out. Now this is 2, this is 90, this is 22.5, and I can find this height. So tan of 22 is equals to 2 by x. X is equals to 2 by tan 22.5. And I'm getting 4.83. 4.83. Now we can find the area of this red triangle, which is 1 by 2 into base into height. So 4.83 centimeters square. And the question said to find the area of the complete octagon. So I'm multiplying it with 16. Any objection with this number 16? Any objection with this number 16?
No, because it's always like 2 times more since we
Any?
already divided the triangle in half. So yeah.
Okay. Okay, so okay, this is entirely different from what we've been doing. So I guess that leaves us with some 3 questions: 10, 11, and 7. So I'll share these 3, and inshallah we'll continue with the new topic and new concept.
Okay.
Anything you would like to ask?
No.
Any question from the homework?
Yes, I had a question about question number 3.
Okay. Third question says find the area of regular polygon with n sides, each of length 2a meters. Okay, regular pentagon.
So all sides
Polygon.
are the same.
So the number of sides are unknown. So let's say this is the case, and I can say that this angle is 360 divided by n. Any objection?
No.
Now I have this one angle, and I know that length of each side is 2a. So this would be 2a. If I just split it into half, now this length is going to be single a, right?
Yes.
and this is going to be half of this, which is 360 over 2n or 180 over n. I'm not changing it because I can see that right here. That's why I'm not writing 180 over n. So this side is 360 over 2n. Now I need to know this height. I'm using tan, and let me name it x. So tan of 360 over 2n is equals to perpendicular over base. Now solving for x, x is equals to a over tan 360 over 2n. Now if I solve for this complete triangle, this is going to be area is equals to 1 by 2 into base into height a over tan 360 over n. Do you agree? For
Yes.
this one triangle. Now, if I just solve for the complete diagram, we knew that there were n sides. So there are now n triangles. Total is going to be 1 by 2 into 2a into a over tan 360 over n 2n into n. Now we just simplify. 2 goes with 2. A into a is a square. N into a is n square divided by the remaining. That is tan 360 over 2n.
So I could do like the first part where it was like the 360 divided by n and then to 2a. But then when I had to like plug tan in, that was like the part where I was confused about. But yeah. So now I know it.
Basically, this was similar to question 2 and few of the questions we did yesterday. Like this 8th one.
Yeah. I think the variables confused me a little bit.
Okay. Now we have sines, cosines, and tangents of angle more than 90. Okay, first thing when we are working in pairs. Same values, okay. Sine rule, cos rule is there, but at a later stage, okay. So sines and cosines of tan of angle more than 90. You have now seen that we find the sine, cosine, tangent by using your calculator, and we used right angled triangle. Now check that sine 30 and sine 150 will have the exact same answers. Sine 30 is equals to sine 1.
0.5 and 150 is equal to 0.5 as well.
And so will all these remaining values give, because sum of these two is actually 180. So we can summarize that it is sine theta is equals to sine 180 minus theta. Sine of acute angle is equal to sine of obtuse angle. For example, if I write sine of 2, that is equal to 180 minus 2, which is sine 178. Clear?
Yes.
Now what happens with cos and tan? Actually, this is a division of 4 quadrants. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. And we write add sugar to coffee. That's a mnemonic to memorize. Add A means all. All are positive. That would mean all acute angles between 0 to 90. For example, we say 50. So sine 50, cos 50, and tan 50 all will be positive. Make a quick check. And let me
Yeah.
bring this on the sheet.
So all is just like everything that is part of that number is into that quadrant.
Yes.
That's positive. So it
Yes.
has to be like 50 degrees. So even if like the tan or sine or cosine changes, like even if it's for example 50, it's all in the first quadrant, right?
It's all in the first quadrant. It remains positive. Add sugar to coffee. If we talk about the first quadrant, which is between 0 and 90, and we take any angle, I'm changing it to 10. So let's say we use sine 10, cos 10, and tan of 10. I'm writing these values as well. This is sine of 10 is 0.174 rounded. Cos of 10 is 0.985 and tan of 10 is 0.176, and see all are positive. Now second one would say add sugar to coffee. S is for sine only. So sine only is positive and tan only is positive and cos only is positive. So sine theta, tan theta and cos theta. Now we will be doing two different things indirectly. I'm taking this second angle as 170. What am I doing? I'm keeping this basic angle same. This is 10 degrees, this is 10 degrees. In the third quadrant, I'm making that 10 again. In the fourth quadrant, I'm making that 10 again. Before we check, do you agree that this is going to be 170?
Yes.
Next, do you
A
agree
170?
this is 190?
No. I mean like the first one, did you say it was 170 or 160?
170.
So but
See
two
again.
times.
See that again. You see this line right here that's making a 10-degree angle with the
Yes.
negative x-axis, and the straight line is 180. So
Mm.
angle up till this point is
Oh,
going
up from that point. I thought you were also including the other 10.
starting from 0, always starting from 0.
Okay.
And this third one, all the way till here, is going to be 3,
360? 350.
10 less
Because
than
it's
360.
almost complete.
Okay. So we are going to talk about 10, 170, 190, and 350. So one thing, if I write sine 10, sine 170, sine 190, and sine 36, so 350. So what is common in all of these? Basic angle is same. What is basic angle? Angle with x-axis. So all of these have basic angle as 10. And I know sine 10 is 0.174. So without using calculator, without checking, I can directly write 0.174 all of these except one thing. Now see, I can see add sugar to coffee. So first one all positive, second one sine positive, but in third one tan is positive, so sine must be negative. In fourth one cos is positive, so sine must be negative. Now make a quick check of all four of these. Sine 10, sine 170, sine 190, and sine 350.
Yep. The bottom ones are negative, but they're
Yes,
all equal to the same numbers.
yes. Just to make it less messy, I'm drawing that again. And this time, let's do it for 20. If this is 20, the basic angle being 20, this would be 160. Do you agree?
Yes.
0, 90, 180, 270, and again ends at 360 degrees. So this third one is going to be 200, and the last is going to be
340.
340. And we don't need to write this again and again. We can see that the basic angle is 20. Now, so for cos 20, cos 160, cos 200, and cos 340. Now, for all four of these, basic angle is same, so would be the value. But one thing, add sugar to coffee. It is going to be positive in the first one and fourth one.
Wait, sorry, just to clarify. So the basic angle being same just means that there's like a 0 at the end. So that's why they're all like similar. That's why
Like whenever they're drawn, they will
they
have
will with the same
the,
difference.
the
Yeah.
angle with the x-axis will be same.
Okay.
We'll do other than 0 as well to clarify. So now I know that first and last is positive. How do we know that? I can see add sugar to coffee. Add means all. First is all positive and last one is cos positive. And in between these two, they will be negative. Now I'm checking for cos 20. Cos 20 gives me 0.9396. So I'm rounding it, makes it 0.940. So 940 and 0.940, 0.940. Value stays the same because basic angle is same and positive negative could be decided depending on the quadrant.
Why
Further,
is the sine and the cos different for which one is negative and which one is positive?
I'll show you. Just
Okay.
let me complete tan and then I'll draw the curve and tell you that how we are deciding that this changes from positive to negative. Uh, Now I'm selecting a non-zero number. Let's say the basic angle is 5. Or let's say you don't know what the basic angle is. And I write here 171, 2, 3, 4. And one thing was fixed, which is 0, 90, 180, 270, and comes back to 360. Now just looking at 171, what basic angle do you think it is?
9.
9. So the first one would be, this angle would be
First one would be 9.
9. And the third one,
Third one would be 261.
180 plus 9 is
189.
189. And
And
the
then
last one,
279.
that is 351. Basic angle is always with the x-axis. These marked ones are 9, not this. This is not 9. Okay?
Wait. So for the last quadrant,
Yeah.
everything else is like the angle, and like the one that we marked is not.
For the last one, this 351. This is actually 9 less than 360.
Mm-hmm.
So
And then
350, keeping the basic angle same.
what makes it like? How is the other one different? The third one?
The third one, that was 9 more than 180. We always start from 0. This is the first 9. Now the second one, I'm going, but I am 9 less than 180. I'm before 180. And then I'm going for the third one. Third one, I just crossed 180. And how much did I cross? I crossed 9 units for 180. And for the fourth one, again, completing, crosses 180, crosses 270, and just before 360, stopped 9
That's what I'm
degrees before
subtracting.
360.
Okay.
So now I'm writing 10 of 9, 10 of 171, 10 of 189, and 10 of 351. First thing which is common is all of these have same basic angle. So they'll have same values. So I'm punching 10, 9, and I'm getting 0.158. This is 0.158. First thing. So knowing this, because the basic angle is same, I'm going to write same value for every one of those. And when we check for positive and negative, we knew add sugar to coffee. So we knew that first and third is going to be positive and remaining are negative. Now you can quickly check that.
Yeah. The first one and the third one is positive.
Yes. So positive and negative, we could directly see by the angle. We would know that it is between 0 to 90 or 90 to 180 or 180 to 270 and 270 to 360. Now, if I just write a number random at random, like 10 to 75. So you just need to tell it as positive or negative.
Negative?
That is negative. So you knew 275 was in fourth quadrant and their only cos is positive. Now, if I say this is 275 and on the other side I say 10 265, will it be negative or positive?
It will be positive because it's still on the 10.
Positive. Now, if I write 10 265 and ask you about the basic angle, now this is 265. So, what would be this basic angle?
It would be 85.
Correct. So, this is 85. So, basically, I know that 265 has a basic angle of 85 and 275, which lies over here. What is this basic angle?
Also 85.
Also 85. So now when we know that 10, 275 and 65 both have same basic angle, so they should have same values and we will only check for negative and positive, which we've already written. So I can say 10 to 65 is equal to 10 to 75 if I just put a negative sign outside, because that was a negative value and negative into negative becomes positive, and finally making these two equal. Another example for the same concept. Let's say I write this 5 and this 175. Are the basic angles same?
Yes.
Let's do it for cos. Cos of 5 should have the same value as cos of 175. And we know cos of 5 is positive and cos of 175 is add sugar to coffee. Cos of 175 is already negative. So when it is negative inside, if I put a negative sign outside, the overall answer would be positive. So I can write cos of 5 is equals to negative cos of 175.
So when we already know it's going to be negative,
Yep,
how is the how is cos 175 already negative?
that is already
We
negative
already
because it
have.
is in the second quadrant.
Mm-hmm.
And why are we putting this negative sign outside? Because of this equality, we are trying to write an equation. We are
It
trying to
has to
write,
have another negative sign.
like, I cannot write cos 5 is equal to cos 175. That is for sure not same. One is
Yes.
positive, the other is negative. So I can put a negative sign and make the both sides equal. Or I can put the sign over here as well. Let's do it with tan because that button is working on your calculator. For
Yeah.
example, I write tan of 3. So on the other side, it would be tan of, what should I write? The angle
It would be 177.
177. Now we both know that one is in the first quadrant, second is in the second quadrant. So this is add sugar to coffee. Whatever the signs are, but they do have opposite signs because we're talking about the first and second. First one, all are positive. The second only sign is positive and 10 is negative. So when they have opposite signs, either I can write, in this case, it is not equal. I can write negative 10 of 3 is equals to 10 of 177, or I can write 10 of 3 is equals to negative 10 of 177.
Oh, I see. Because
Yeah.
if you only add the negative on the tan.
Yes.
For the cos example, so
Yep.
no, the thing I was like confused about was, so if we already have a negative on the outside of the brackets, why do
Yes.
we have an like negative on the inside, which cancels them out? I
These are
know
two.
it's supposed to cancel them out, but
These
like
are,
why do we have an extra negative inside the brackets?
yeah, consider them these two things. Now inside the bracket is a negative number, cos 175, because it is in the second quadrant. So when it is a negative number, it cannot be equal to a positive number, which is cos 5. So if we put a negative sign outside, we are actually multiplying two negative numbers and overall making it positive. And now this could be equal to the positive number.
Didn't we put the negative number? Oh, so we're just trying to get the same number. It doesn't matter if it's negative or positive. So shouldn't it also cancel out in like the tan example as well? Or
The value could be same, but in opposite sign. For example, I cannot say that 5 is equals to minus 5, but this is what I can say.
yes.
I cannot say that 7 is equals to minus 7, but this is what I can write.
So tan 3 does not equal to negative tan 177.
Tan 3 equals to negative 177. It does not equal to positive 177. Because tan 3, if I just punch in, I'm getting 0.052. So this is 0.052. And on the other hand, that is negative 0.052. So these two numbers are not equal. The basic
Oh, so
angle
we
is just
add the
telling me
negative to make it positive so that they equal.
yes.
In the first example, the number was already negative. That's why we had to add another negative to make it positive so that they would match, right?
Yes.
Okay. So we know the number is negative by checking it, right? Like by
Yeah.
checking
Even
175.
even without the calculator, we just need to know the quadrant.
Okay.
See,
So um,
if I write sine of 20 without drawing the quadrants, what would it be, positive or negative?
sine of 20 would be negative. Oh no, positive because it's in the first quadrant.
It's in the first quadrant. And if I write sine of 160, positive or negative?
It's positive because
It's
it's in the
positive.
second.
So add sugar to coffee. The first one 20 is positive. The second one 160 is positive, and both of them have the same basic angle. Both of them have 20 degrees with the x-axis. So I can write sine of 20 is equal to sine of 160. Now this time we do not need any negative sign to adjust. They are equal in magnitude and they are equal in size, in
Yes.
size. So which brings us down to sine of theta is equal to sine of 180 minus theta. And for cos of theta is equals to cos of 180 minus theta, and with the negative sign. This second part, this part right here, ensures that they have same basic angle. And the third one with the tan is tan of theta is equals to negative tan 180 minus theta.
So when we were doing like the cos
Yeah.
before, so were you just showing it like an example just to make it clarify by adding a negative to it? Or what makes it different than like for example the tan example where we didn't add a negative but it's still like turned
Tan,
into a positive?
tan and cos would show you the same results, because for both, for cos and tan, for both, first is positive and second is negative for both. Cos positive, tan positive, and in the second case cos negative, tan negative, because for both the signs are same. So examples could be same, numbers could be same, only the magnitude obviously would be different, like cos 7 is not the same as tan 7.
No, I mean, could you scroll up a little bit?
Cos of 173 and not 10. But I do know that this complete box is positive and this complete box is negative. So how can I use this equality sign? They cannot be equal. So I'm bound to put a negative sign here. And
Yes.
I just punch to see cos 7. I get 0.993. So this is 0.993. And on the other side, this only would be negative 0.993. To make them equal, I have to put this negative sign.
Could you scroll up a little bit?
Yeah, sure.
A little bit more to like the cost example.
Yeah. 5 and 175.
Yeah. So it cost 175 is already negative.
Already negative,
We already
yes.
had to put the negative inside of it.
Yeah.
So is like inside the brackets the answer what we get, which
Yes.
is already negative?
Yep.
Okay. Okay,
So
so that
I'm punching cos 175 and I'm getting negative 0.996. This is negative 0.996. So this would be 0.996 only. And both of these cannot be negative, so we have to put a negative sign. Now this equation is equal left hand side equals right hand side.
okay.
Now your question, how do we know this is positive and negative? So when we draw the curves, which is at slightly later stage, but let's discuss sine theta. Curve for sine theta is like this, and the main divisions are 360 This is 180. This is 90. This is 270. This highest point is 1. This lowest point is -1. Now you would also observe that all the values we were solving for sine and cos were all starting from 0 point something, 0 point something, because that's less than 1. It would be equal to 1 when you punch sine 90, and it would be equal to -1 when you punch sine 270. Now see, if I just split them into 4, sine is positive in first quadrant, positive in second quadrant, negative in the third, and negative in the fourth. Cos curve. This is the cos curve, and this ends at 360. Midpoint is 180. The other two mids are 90 and 270. Highest value being 1, lowest value being -1. So this is positive, negative, negative, and positive again.
So this one doesn't start at 0 and doesn't end at 0 either.
That's right.
That's the difference. Okay.
And now tan. Tan actually has no limits on the y-axis. So we make the 4 divisions first. This is 360. This is 180. Now I'm making a dotted line at 90 and a dotted line at 270. Now see, tan starts from 0, but it never touches 90 degree. And it never touches 270. And this is 360. Now just can you take your calculator out and just punch tan of 89. Tan 89.
89?
Yep.
57.3.
57.3. Now write tan 89.9.
0.9. 572.
See the value shoots.
Yeah.
Now write tan 89.99.
5,729.
See this green line when it approaches 90. This never touches 90, but it shoots up. Now type tan 90.
Oh,
Math
it's
error.
one big number. Yeah.
So from this graph, you can see this is cos theta, this is tan theta. One thing that it is positive, negative, positive, negative. First and third is positive, and second and fourth is negative. And apart from that, when the angle is actually close to 90, it shoots up on either side. On the other side, like it could be tan of 90.01 or tan of 90.1. When it comes closer to 90, you'll get a negative value, but with a high magnitude. And when you type tan 180 or 0 or 360, you can tell that it is 0. Now, as we've done 2 of the types, I'll give you a quick recap of the first type. The second is right in front of us. Let's discuss this first. So by looking at it, I can actually tell the values for 90, 180, 270, 360, and 0 for sine. So if I'm writing sine 0, sine 90, sine 180, sine 270, and sine 360. And all of these values I'm looking on the graph, and I can see that sine 0 is 0. I'll slow down here. Sine 90 is 1. Sine 180 is again 0. Sine 270 is -1. Sine 360 is 0. Now for cos, let me write this and you'll tell me the values. This is cos of 0. cos 90, cos 180, cos 270, and cos 360. So just read it.
Cos of 0 equals to 1.
Yes, 90,
90 equals to 0.
180,
180 equals to -1.
-1, 270,
0.
0,
And
360.
360 is 1.
360 is 1. Now for tan, we can see that 90 and 270 are optional. They're math error. So we're writing tan of 0 only, skipping 90. Tan of 180 only, I'm skipping 270. And tan of 360. So tan 0 is
0.
0. 180 is
It's at 0 as well.
0 and 360.
0.
0 again. So we can answer like 0, 90, 180, 270, 360 for sine cos tan, apart from tan, 90 and 270. And then we have some more angles. I think I did this with someone else. Do you remember we doing square? No, I think I did with this someone else. Consider this a square of side 1 each. So this is 1, 1, 1, and 1. Now we draw a diagonal, and I need one of this triangle, and I'm pulling that out. So we take that triangle out. And now I'm left with this 91, 1. When we know both of these are equal, this brings us down to 45, 45, making it isosceles triangle. And this diagonal length, if I solve for x, this is x square is equals to 1 square plus 1 square. And this is square root 2. Have we done this earlier?
Not with you, but I know this one.
Okay, that's good. So one more triangle quickly, and then we'll write the values. So I'm drawing an equilateral triangle of side 2 each. And equilateral, all the angles are 60 degrees. So we split it in half and pull out the required triangle. Now this is 90, this is 1, this was 2, this was 60 because we cut it in half. This is now 30, and you solve for this. This is 2 squared is equals to 1 square plus x square. So this comes down to square root 3. Now I can write sine 45, cos 45, and tan 45. And then I can write sine 30, cos 30, and tan 30. And lastly, sine 60, cos 60, and tan 60. So I'm looking at the first triangle. And sine 45 is perpendicular over hypotenuse, 1 by square root 2. Cos 45 is base over hypotenuse, and tan 45 is perpendicular over base. So just by using these, sine 30 is 1 by 2. Cos 30 is square root 3 by 2. Tan 30 is 1 by square root 3. And sine 60, can you tell me what sine 60 is?
Sine 60 is square root 3 over 2.
Square root 3 by 2. Cos 60?
Cos 60 is 1 over 2.
Correct. And tan 60?
Tan 60 is equal to square root 3 over 1.
Square root 3 over
Over
1. So generally, we could answer for 30, 60, 90, 45, 180, 270, 360, and 0. So 0, 90, 180, 270, 360 from the sketches and graphs, and these angles from the triangles. And in between all of these, we would definitely need a calculator to solve. Now
So we
see,
can plug the degrees into the triangle, including the actual degrees as well, right? That's
yeah, other than like 30, 60, 90, we won't need a triangle. We'll directly use a calculator.
okay.
And in both of our exam, calculator is always with us, but sometimes the examiner would say that show all your working or give you answer in exact form, or he may say that without using calculator. So we should know how to solve. We will still use it to check if our answer is correct.
Yeah. So only for the questions like sine and tan, they won't be asking that because we can't really solve it without a calculator.
Now they can ask, but other than these values, now see if this is cos 30. You and I know that this exists in one of the triangle, right?
Yes.
So cos 30. Now, who would know that actually I am drawing this triangle? This is 30, this is 60, this is 91, 2, and square root 3. Just by looking at this triangle, I can see that cos 30 is square root 3 by 2. Square root 3 by 2. But who would actually know that I use this triangle? Maybe I'm just punching cos of 30 and just getting square root 3 by 2. But what am I doing wisely? I'm not skipping any of these steps. So when I see cos 30 and cos 330, I do realize that 30 lies here, which actually makes this 30, and 330 lies in the fourth one, and this is 360. So the difference is again 30. Basic angle is same. When the basic angle is same, value is same.
Okay, yeah.
So let's see what the demand of question was. So in the first one, it says use a calculator to find each of the following. So yes, we're using it. Sine 30, use your calculator 150, and we would just realize that we are getting exactly same values because some of these two is 180, 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 and also that both in first and second quadrant sine is positive. Now for this one, cos 30 would be positive and cos 330 is positive because it is first and fourth. 60 again first, 300 again fourth, first, fourth, first, and fourth. Apart from that, do all these have same basic angles? Yes, they have. First one is 30. This is 330. That is actually 30 less than 360. Check for this one. Do they have same?
Yeah. They have the same basic angle because it's 360 minus 60.
Correct. Now for 10. This is 30. This is 210. So 30 lies in the first one. 210 lies in the third one. This is 30 right here, basic angle. This is 180 and this is 210. And what is the difference between 180 and 210?
Oh. It's also going to be 30.
It's also 30. So 1030 and 210 are actually equal in number and equal in size as well because it lies in add sugar to coffee. It lies in the first and third where 10 is positive. Clear?
Yes.
Now this is a sine curve. We did it for 360 only. We started at 0 and ended at 360. Now, all of these curves, they do go in both of the sides. For example, so if you are sketching for sine, I actually stopped here, but we can go beyond that. So 360 plus 360 is 720, then into 3, and so on. And so in the negative side, minus 360, and this is minus 720. So for both, all three, sine cos tan, we can write for whatever domain the examiner would ask. So from 0 to 360, this is one cycle, and then another 360, and then another, and then another. So this is sine curve. This is cos curve, which starts from 1, ends at 1. This is the cos curve. Let me sketch outside so you'll recall. And this was sine. So it moves to both directions. And this is cos. We can continue in both directions. Same goes for tan. So till 360, this is 360. So we knew we need to draw 4 of these dots, equal distances. The first one is asymptote. The third one is asymptote. We're not going to touch it. This is one complete tan for 360. And if we wish to draw beyond that, so yes, we'll just continue this and this and this on both the
So
sides.
in the exam, is it going to ever ask us to draw it? Like draw one of them?
Yeah.
Okay.
For example, it says to draw sine theta for 0 to 180. So now this would depend on individual practice. For me, I always do this. I quickly sketch sine curve rough 360. Now the question was from 0 to 180. I know I should stop here, but this is going to be my neat and final response. I will just draw one half cycle, write 180 here. This is 0 and this is going to be 1. That's it. Sine theta and this is theta. Or in the previous case, this was 1 and minus 1 because I never left that value. Even if we just mark it, would make no difference.
So that's the level of like detail we need to put into it. Just like sine theta, and then the 1, 0, -1, and then the
Yes.
curve. Okay.
So graph of sine, cos, and tan. Now some worked examples. So which acute angle has the same sine as 120? Acute angle, same sine as has the same sine as 120. So
60?
60, right? Because 120 has a basic angle of 60. Or else we can just directly use this identity. If I just write sine 180 minus theta, what you answered quickly was the concept. So if I'm using sine of 120 on one side, this would be 180 minus 120 on the other side, which makes it sine 60 is equals to sine 120.
So that's just the working, right? We have to put that during the exam if they ask us.
We can directly just write, you also did 180 minus 120, right?
Yeah.
So if I just say what is the basic angle of 150, you would do this.
So we can just write that?
Yeah, it is always the difference from 180.
Okay.
Because we won't have the same values if they both do not add up to 180.
Okay.
They should add up to 180. Okay, express each of the following in terms of another angle between 0 and 180. So cos 100, what would be the other pair?
80?
Is 80. That's right. Now be careful when you write this. Cos of 100 only, answer would be positive or negative?
The answer would be negative.
Negative. And cos of 80, answer would be positive or negative?
It would be positive.
Positive. Are these two exactly equal?
Yes, they are.
No.
The number, but not the sign.
We just agreed. So we'll say they're not equal.
Oh, even with the sign?
So what should I write? If I have cos of 100 and I'm not allowed to write it, I can write negative cos of 80, making it exactly equal. Because I cannot write cos of 60, we know that this is not sum of 180, right? So there's no confusion in like 60 and 80, right?
Yeah.
So when we
Because,
clarify the positive negative sign, we know deep down that cos 100 is going to be negative. So in
yes.
order to have the same value, we put a negative sign with cos 80.
So we can't put a negative sign in front of cos 100 because the question put it as a
Yeah,
positive?
yeah, that's the question. We're not changing it. So we're
Okay.
just supposed to write our answer or response. We can't change the question. See, in B part, we have negative cos of 35. Now think about cos of 35 only.
It's positive.
It's positive. And what is this main question completely? This makes it positive or negative?
Negative.
That makes it negative. So now we know deep down that it is negative. Yes. So cos 35 and outside it is a negative sign. So I need to write something between 0 and 180 to give cos, give a negative value, which should be equal to this. So it makes easy for me to think when I draw this diagram. This is 35 and we know that we are between 0 and 180. So I'm not drawing anything in third and fourth. So if this is 35, this needs to be 35 in the basic angle.
So 145?
So this is going to be 145. Now, before I write my final answer, I now know that this is for sure 145. Now, cos of 35 with a negative sign was negative already decided,
Yes.
and
So
cos of
that one
145
is
is
already negative, so we don't have to put
positive.
a negative sign in front of it.
That's right. So this is our final answer.
Okay.
Okay. Solve the following equations, giving all possible solutions in the range 0 to 360. Sine of 1 by square root 2. Now, obviously, 1 by square root 2, we can actually not use this curve. Like, how would I know where 1 over square root 2 is? If it would have been like 0.5, yes, I can see. 0.75, I can see. 0.25, I can see. 0.25. Now, if someone would say 0.23, how would I know? Where do I draw the line? So we are going to use our calculators and solve for sine theta is equals to 1 by 2. And it says between 0 to 360. I'm writing this question again. 0 is less than equal to, this is less than equal to 360 degrees. So we are finding theta, and the question is sine of theta is equals to 1 by square root 2.
So sine inverse.
That's right. So first of all, theta is sine inverse 1 by square root 2. I'm going to use my calculator and shift sine of 1 by square root 2 gives me 45. So this is 45. Now I know that it is already 45. If there was no restriction, I would know this is 45, this is 135, this is going to be 360 minus 45 is 315. And this is going to be 180 plus 45, which is 225, right? Because
Yeah.
all of these have same basic angles. But there is a restriction. Firstly, we cannot go beyond 360. Secondly, sine theta is square root 1 by 2. If I just write sine 45, yes, that is 1 by square root 2. If I write sine of 135, yes, that is 1 by square root 2 because they have the same basic angle. But I cannot write sine 225 because that is negative 1 by square root 2, which is not the same as 1 over square root 2. So all the values of theta would be theta is equals to, now we know these are the basic angles, same basic angles, but we are also looking for positive response. So theta is equals to 45 degrees and 135 degree. This is my final answer. Let me
So
do some more.
excluding the negative numbers, only the positive numbers, because it didn't say we had to put the negative numbers.
Yes.
Okay.
Like it actually told us to write the positive because sine theta is equals to positive 1 by square root 2.
Yeah.
Now
Okay.
see, tan theta is equals to 3. New question, 0 to 360. And the question says tan of theta is equals to 3 only. Now, first of all, I need to know the angle. So tan inverse of 3. This is giving me shift. Tan 3, make sure calculator is in degree mode. This is
71. Yeah.
71.6. 71.6. Now, for sure, we know that tan is positive. Any doubt?
Mhm.
So when we move here, this
One,
is
six.
add sugar to coffee. Now we're going to strictly stick to what is required. Tan should be positive, so it is either the first one or the third one and nothing else. So I know this basic angle is 71.6 and
Yes.
this basic angle is 71.6. So I would clearly know that theta is equals to 71.6 and this, which is 180 plus 71.6, making it 251.6. So if we just punch in these two values, we'll get 3. Tan of 71.6 is 3. Tan of 251.6 is 3. Cos x is equals to negative 1 by 2. Cos x is equals to negative 1 by 2 and we are solving from 0 to 360. Whatever the value would be, where is cos negative?
Cos is negative in the second one and the third quadrant.
Second and third. So these are going to be our final answers, whatever it is. Now, when we solve for basic angle, I should have written alpha here. I was just not really in a position to introduce a new variable. Now let me clarify. Whenever we find a basic angle, we name it alpha and then we solve for theta. So whenever we solve for basic angle, we name it alpha, and alpha is found always using positive values. So I'm going to write cos alpha is equals to 1 by 2. Alpha is equals to cos inverse of 1 by 2 and basic angle is shift cos of 1 by 2, that is giving me 60 degrees. Now this is the basic angle only. Basic angle has nothing to do with anything which quadrant and or something. So I just now know that this is basic angle. Having said so, I would know that x is equals to what is this first angle?
120.
120. And the second one?
The second one is 240.
240. So this is our answer. So now if you see cos of 120, you will get negative 1 by 2. If you see cos of 240, you will get 1 by 2 because all these three have same basic angle, first thing, and they lie in second, like 120 and 240 lie in second and third where cos is negative.
Okay. Wait, if it's like, that, wait, so there's a positive and then a negative under it. Is that only for in front of like a number? Is that only for when it's square root, or can it be just for any number?
Positive and negative both, that would be square root. Suppose we have like sine square x is equals to 4, if this is my question. So what I would do is sine x is equals to like square root both sides. Now this is going to be plus minus 2. Now I know plus minus both. So for basic angle, what we do always is alpha is equals to sine inverse of 2. I'm checking for basic angle. Shift sine of 2. That's a math error. Why? So I didn't thought see through that because sine lies between 1 and minus 1. Okay, so quickly changing the question. Let's say this is sine square x is equals to Anything less than 1.
0.5.
0.5. So square root both sides. I get sine x is equals to plus minus square root 0.5. Keeping it this way for now. So basic angle is sine inverse of square root 0.5. The shift sine of square root 0.5 gives me 45. Now, because we knew that it was positive, negative both, so that's how we now find all four angles from 0 to 360. But still, if the examiner would say find solve from 0 to 180, we'll solve only for first two. But if it says 0 to 270, we'll solve for first three. 0 to 360, we'll solve for first four. And we know this is 45. This is 135. Is it 135? Yes. And 180 plus 45 is 225. And 315. So in this case, x would be equal to 45, 135, 225, and 315.
Because it's a square root, so it has to be all of them, no
All
matter negative or positive.
yes. If the same question says solve for 0 to 220, so it would be 45 and 135 only, because 225 is more than 220.
Okay.
Now see, sine inverse of 1 by 2, which is positive. So that's positive, and whenever the line is drawn, I can see two intersections only. If it would have been positive, negative both, we will have these two answers as well. So it is giving us positive for now. Use your calculator to find the solution of tan inverse. We just did that, 71.6. We solved all these. And this is the exercise. Express each of the following in terms of the same trigonometric ratio between 0 and 180. So cos 120.
60?
That's right. May I write negative cos 60?
Yes. Because it's on the second quadrant.
So on this second
The
one.
first quadrant.
Try this F part. Negative cos 140 is equals to
Cos 40.
cos
Just
of, correct. Cos 140 alone was negative. The outside negative makes it positive, and cos 40 is also positive. So yes, this is the answer. Okay, solve. Question number 2 is just like these questions.
Yeah.
Just having a look if there is something we need to discuss for each of the following. Find the smallest positive value of x. Okay. Solve giving all solutions between 0 to 360. Yes. Okay. So this particular exercise will be solved using the concept we studied today. I'll share this with you.
Okay.
I hope things are clear.
Yes.
And I did it on this sheet on purpose. You have access to this, right?
Yeah. On my mom's account.
Okay. So anything you would like to ask before we end?
Um.
This
No. Nothing.
definitely like push you to think a bit.
I like it. I like this,
Should we add these questions as homework?
Yes.
Any using these?
Yes, I did.
Sure.
So for question 3, you see question 3E.
3E. For each of the following, find the smallest positive value of x for which this equals this. Okay. So when I look at this question, I am looking at sine 270. Sine 270, on the other hand, sine of x. So when I look at sine 270, this was 0, 90, 180, 270, 360. Now there are two things. One was this add sugar to coffee. The other was the graph. It is easier with the graph. I didn't actually realize that 270 was exactly on the axis. I was looking for basic angle. I'll tell you with both. So if I quickly sketch this, we know that this is 0, 180, 360, and in between we have equal divisions, which is 90 and 270. So if you just look at sine 270, we get a value of -1, right?
Yes.
So I need a value of x such that it should be least and I should get another -1. Smallest positive value of x for which sin x is equals to sine 270. That is -1.
So sorry. The answer has to be something like -1, or the answer is -1.
I'm thinking a bit over it. No, the answer should be -1. Like x is not -1. X should be angle. So 270 basically is giving me 90 degrees as basic angle. So, like obviously sine 90 is +1. And to get -1, there is nothing which we can do other than this, which is obviously more than 270. So that's not our choice. And when I come back on the opposite side, I get -90. It's telling me to select positive value. That's not fair. Let me just open up. Question 3E. Yeah, see, it's not changing. So it is the same. Why, I'll explain. So sine 270 is equals to sine 270. For example, when we write sine 10, we know we can write sine 170. Are you okay with this? Sine 10 and
Yep.
170. So these are actually two different values, but there was one another condition that we should get same and positive, least and positive value. So sine 270 is already equal to -1. This is sine 270 equal to -1. So at -1, if I just put this horizontal line, I can get another 270 at this angle. But I have a condition. I have to stay positive and I have to stay at the least value. So this is positive, but this is not the least value. So which I fall back to 270, keeping it positive and least. So there's no lesser value than 270, which will give me -1. Clear?
Yep. And then also it was question D as well.
3D, doctor?
Yep.
Okay. So cos of x, again smallest positive value of x. So cos theta, if I just draw these angles, first of all, it is telling me cos negative 45. So cos of negative 45. This is clockwise. Anti-clockwise are all positive angles. Clockwise is negative. So we are talking about this angle. This is 45 and we're talking about this. So when I look at this, I know that add sugar to coffee. So cos of negative 45 is actually a positive value. Do you agree?
It's actually negative
Positive.
because it's an angle, right? It's actually
Angle is negative, but the
Yeah.
final answer is positive.
when we like plot it or when
Yeah.
we put it on this.
If you
Okay.
just punch cos of minus 45, you will get square root 2 by 2, which is positive.
Okay.
And we know that another positive would be in the first quadrant. So this is supposed to be 45. So I can write cos of 45 is equals to cos of minus 45. So x is 45.
Okay. So also for like the first example, sine 270 equals to sine 270.
Yeah.
So like what do we need to know before knowing that it's going to be like the same answer for it? Like what should we check beforehand?
One thing he said positive. So I have to stay on right hand side. Secondly, least. He said least.
Mm-hmm.
There was no such option to get minus 1. Look, if you're looking at this, this is 90, 180, 270, and 360. I'm just hovering over the options. 90, 180, 270, 360. And we know that sine of 270 is minus 1. Sine of 360 is going to give me 0, not minus 1. So I can only select these values. This is minus 1, and this is going to the next value, which is actually 270 plus 360 after the complete cycle, that is 630. Plus 360, next would be 990. 990. So all these are giving me minus 1, minus 1, minus 1. If I have to stay positive, I can write sine 270, sine 630, sine 990. That will give me minus 1. But the second condition was that you have to select the least value. So this is the only least value, which is positive and least, giving us minus 1.
Okay. So it has to be 270. Okay.
Yeah. If there was no condition, we could write sine 990. That is still giving us minus 1.
Okay. And then also question 3H.
GH, okay. Cos 2x is equals to cos 540. Actually, we didn't do this. I'll just quickly give you the review and then solve this question.
Okay.
This is a double angle. He said cos of 2x is equals to cos of 540. Let me just show you the traditional way and then I'll tell you what the difference is. This is 540. Clearly, we can see this is more than one cycle. So I start from 0. This is 90. This is 180. This is 270. When it touches back again, this is 360. Now I need to know how much more is that. So I'm checking 540 minus 360.
180.
180. So which brings me at this point. This is 540. Now see, add sugar to coffee, one thing, and this sketch. This is 360. This is 180. So we know at this point, cos is negative. Add sugar to coffee. This is in second quadrant. Even if you consider that this is third quadrant, both the cases, it is negative. Right?
Yes. Because
So
it's on the sine.
yeah, cos of 180 is giving us, cos of 540 is giving us negative 1. Cos of 180 is giving us negative 1. So -1, the least possible option is cos of 180. So if I just compare it with this left hand side and right hand side, I can write 2x is equals to 180 and x is equals to 90, which will give us -1 for this question.
So because 540 is in the second quadrant, we can just take 180 and put it, like replace it with it?
Yes, because they have the same basic angle.
Okay.
And the other thing was, if I just say that cos x, this is my sketch, which starts from 1, -1, and 360. And when we write cos of 2x, this is the difference. 2x means there are two cycles in 360. So this one cycle would end at 180, and another cycle would end at 360. So that's why we are getting x 90 and -1. X is equals to 90 is due to this thing. So we can choose either method. Either we go for 2x sketch, or we simply just assume that this was written as cos of y is equals to cos of 180. So we solved for y, that y is equals to 180, and then replace it back. 2x is equals to 180 and x is equals to 90.
I also had a question about question 5.
Yes. Solve giving all solutions between 0 and 360 degrees. Okay. This is a very good question. Quadratics and trigonometry both mixed. The question says 8 cos x whole square, and you need to know one thing, that cos square x or cos x whole square are exactly same. This is just the writing ease.
Okay.
Minus 10 cos x plus 3 is equals to 0. I'm looking for if I can find the perfect split. 8 3 times is 24. 1 into 24, 2 into 12 is giving me 12, yes. So 8 cos square x minus 12 cos x plus, no. When I multiply these two, I'm getting negative. So for the
So
2
sorry,
into
how are you
12,
trying to split it?
yeah, I'm trying to split it. If I don't get it, I will use quadratic formula.
How are you trying to split it?
Midterm breaking. Remember this? X square plus 5x plus 6. X
Yeah,
square.
and then in the middle I'll use.
Yeah, this is midterm breaking. So basically, this is squared. This is squared. Then this is raised to power 1, and then there's a constant. So I'm using this 8 minus 10 and 3 to adjust.
Oh, okay.
6 into 4, I think that will do. Minus 6 of cos x minus 4 of cos x plus 3. Now these two adding together are giving me minus 10, multiplying are giving me positive 24. I'm taking out common from first two. This 2 cos x, and I'm left with 4 cos x minus 3. And then I'm taking out -1 as common and writing 4 cos x minus 3. So you can see these two brackets are same. We can again take it out as common. So 2 cos x minus 1 into 4 cos x minus 3 is equals to 0. Now split solving them separately. 2 cos x minus 1 equal to 0. 2 cos x is equals to 1. Cos x is equals to 1 by 2. On the other hand, 4 cos x is equals to 3. Cos x is equals to 3 by 4. Now the question said that giving all solutions between 0 and 360, The graph actually continues, it never stops. So there's a limit, we are going to solve it from 0 to 360. Now, whenever we are at this stage, we always need the basic angle first, and that is solved only with positive values. Luckily, we got both the positive values, 1 by 2 and 3 by 4 were positive. Even if they were negative, I would have chosen positive sign to find the basic angle, and then later on I'll do all the working. So shift cos inverse of 1 by 2 is giving me 60 degrees. This is the first basic angle. On the other hand, basic angle is cos inverse of 3 by 4. That's giving me 41.4 degrees. Now, one by one, I can see that this is positive and cos is only positive in first and last. So I'm not drawing any angle in second and third. Add sugar to coffee. And I know that this is 60 and this is 60, both basic angles. So my x is going to be 60 and 300. Are you clear where the 60 and 300 is coming from?
Yep, because 300 minus 60, and that's just the basic angle.
Very good. On the other side, again, it is positive. So first and last only. And this is 41.4 and 41.4. So these x are going to be 41.4 degrees. And the other one is 360 minus 41.4, which is 318.6. Last step, we just consolidate them. 41.4 degrees, 60 degrees, 300 degrees, 318.6 degrees. Now, whenever we will punch these values in the first equation, we'll get 0. Obviously, a very close value to 0 because this is not the exact answer, it's rounded.
In the answer sheet, it would give more than one answer to like a question. So are we supposed to find all those answers, or is it okay if we just like write one of them?
Yes, we have to find all of all the questions say so.
Oh,
All,
all solutions. I mean for like the past ones, like for question 3 and like question
now,
question
the
3.
question 3 was restricted us actually with the smallest value.
Okay.
For example, if there was no restriction for the smallest value, if it just says write positive values or within 360 or within 720, and if the question is sine of 170 is equals to sine of x, if there is a restriction to stay positive, I can write sine 10 first thing. I can write sine 190. I can write sine 350. Are you getting it?
Yeah.
Basic angle for 70 is actually 10. Now I'm using this 10 with all the x's, and sorry, one mistake. Uh, Sine 170 is actually positive. So add sugar to coffee. If I need to stay positive, I have to stay in first and second quadrant only. So I'm changing these two. These are negative. Now, what will this give me? This is going to give me 370. And if I just keep on moving, that is going to be 530 and so on. But the question restricted. Even in this case, if the question would say that stop before 720, so we'll complete our 2 cycles and write all the angles in those uh, brackets.
Okay. Okay.
Any other question?
No, everything else was good.
Okay. Now, this is sometimes going to be helpful. For example, we use our calculator. What the calculator does is it always gives you the least answer. So if I am getting an answer like sine, well, like angle is equals to 30 degrees, but I can clearly see on the triangle or even in the statement if it is written that it is obtuse. So I found that x is equals to 30. I would know that the other angle is 150. Now we are going to use this basic knowledge. This is sine and cosine rules. A quick revision. We used some people have curly brown hair through proper brushing. Now there were different words. Perpendicular could be said as opposite, base could be said as adjacent, and opposite over adjacent. These were all applied on right angled triangles. Now there are two new formulas. One is sine rule and cos rule, which could be applied to any triangle other than 90 or 90. You can apply this on both, but definitely it's a bit one extra step more. So we just use the traditional ones for right angle triangle. So sine rule is if you see the triangle on the right, and you can see some formulas written as well. So they work in pairs, A and small a. So capital letters are mostly used to represent angles. Small letters are used to represent sides, that is length. So how do they work in pairs? If we are talking about sine A, then this side A is this. They work in pairs. Sine A divided by A, sine B divided by B is equal to sine C divided by C. We can write this formula in one go, but we will always be using two pairs, in which if you can see this pair sine A and B, the three sides would be known, one would be unknown for this formula to be usable.
So
Another
they're
thing is
always
that,
opposites, right?
yeah, another way to use the same formula is A over sine A. But remember, if I use sine side in a numerator, I'm going to keep this side in numerator till I complete the entire question.
Okay.
So that's a simple reciprocity. There you go. Sides are in numerator over here. And then we see a worked example. In triangle A, that is 80 degree, B is 30 degrees, side BC is equals to 15. Calculate the size of C and lengths of the side AB and C. So the third angle and two missing sides. Sometimes question would say solve the triangle. Solve means find all the missing values. So first of all, easy task first. I can
70.
find very good. So that is 70 degrees. Now choose one side which you wish to solve.
AC.
AC. Now if I see that side AC, I'm looking at that letter B, I'm writing B for myself. Less variables, less confusion. But one thing is for sure, they always work in pairs. Even if you write X, Y, Z, examiner has no issue with that, as far as we are plugging in the right values in the right place. Now B is unknown. I'm writing B divided by sine 30. Pair complete. On the other side, obviously, I will never choose this 70 because the opposite side is unknown. So
So
I'm selecting
sine 80 over 15. I mean, yeah,
yes,
15 over sine 80.
yes. And now comes in calculator. So B is equals to, I'm just saving the working space. We do have to show all the working steps in exam. 15 by sine 80 times sine 30, and it is giving me 7.6156. 7.615, so 2 centimeters. Now the next side, I'm never going to use this 7.62 as far as I have some option which is already provided by examiner. Because if I made a mistake with 7.62, I'll mm, get a wrong answer for AB as well. So side AB, I'm labeling it Let me label it differently as y. So y over sine 70 is equals to 15 over sine 80. So y is equals to 15 by sine 80 times sine 70. So I'm getting 14.31, 14.3 centimeters. Now see one more thing. 14.30. You see, angle 30 is the least angle and the side opposite to it is of least length. And then greatest angle is 80 and the longest side is opposite to 80. Now I want you to do one thing. Sine in your calculator is actually working. So if I just write 15, 80, and I'm writing as 150 degrees over here and asking you to find x. Note that these two triangles are same. I've just replaced 150 with 30. Find x.
Is it 7.62?
7.62. You see, we're getting exactly same value. Can you explain why?
Because 30 and 150, when you add them together, it equals to 180.
Yes. So the
One
calculator
base
will never know this difference. Calculator would never know this difference. Only you can differentiate. Now, if this angle is correct, that is obviously not correct because the sum is actually making it more than 180. So we would say that this is ambiguous case because it is not possible to get a smaller side opposite to larger angle. So there is some mistake. Either we need to replace the angle or the entire question. So calculator would never know. It will always, whatever you function, calculator always uses the basic value, basic angle value.
This question will never be on the exam, right? Like the
No,
wrong one.
no.
Okay.
If it is there, it would be clearly mentioned in the question that see if it is correct. So we'll get a
Oh,
hint that there might be a mistake, or somehow the examiner gives you an answer and says that Ali got this answer and Sana got that answer. Check who is correct. In either
okay.
cases, we are definitely going to solve it and see if we get the same answer.
Okay.
Okay, we have to find angle E and F. I'm going for E first. Actually, I
Sugar.
did not find F first
Yeah.
because the side opposite to F is unknown. Sine E, and notice one more thing. When I was looking for the sides, I chose to write the side first. Now I'm looking for the angle. I'm writing the angle first. That reduces the working steps. You don't have to actually cross multiply. This is already on left hand side. So sine E divided by 10 is equals to sine 34 divided by 7. So sine E is equals to sine 34 over 7 times 10. You can use your calculator along with it, but I have this habit to write in complete form till end. Sine inverse sine 34 by 7 into 10. Now I'm going to punch this completely in one go. Sine 34.
I should be doing this with you, right?
Yeah.
Okay.
So I'm getting 59.3. There are two benefits if you're doing it together, because sometimes there's a lot of working involved. We can always cross check if we're getting same answers. And secondly, you need to get fluent in use of machine.
Yeah. Okay.
And now for angle F, 180 minus 34 minus 59.3. 86.70. Clear?
Yes.
This is sine rule. Mm. Mm. E is 53. Why 53? Quickly rechecking it. Sine 34 divided by 7 into 10. Shift sine of answer. I'm still getting 53. Oh, so why did I write that? I'm getting 53.02. Why did I write 59? 53.02. So 53.0. Are you also getting 53?
I wasn't able to finish my calculation. So I'm not sure if I would be getting 53 as well.
Okay. 180 minus 34 minus 53 is 93. 93.0. Okay, angle E is opposite side. This. 53 done. But there's actually second angle E such that E is equals to this. 127. Yeah, that is possible. Okay. Now, what are we learning from this concept? Now, suppose this diagram was never given. If this diagram was never given and we have these values, one possibility could be the one which is already drawn. Second possibility is that we still draw df as 10, which is given here. df is 10 and ef is 7. So if I just keep this as 34 I can also draw 7 this way. Like if I just draw 7 on this side. So in that case, when I'm solving for this E, calculator still gives me 53, which is this outside angle. So 180 minus 53 is giving me 127. So if that's 127, I can find two possible values of x, f, which is 180 minus 34 minus 127. And I'm getting 19. And we just did a practice that sine 30 and sine 150 are giving us same values.
So this means that it has to be giving us a diagram for us to know like lengths and everything correctly.
We will be going for, through both cases. When diagram is given, well and good. If not, we will solve like the question would say that find the possible values. The possible size of. So there are two different possible sizes for F and E. If E is 53, we're done with F, and the other is also possible.
So we have to write 53 or 127, right?
Yes.
Okay.
Okay, find X. Question 1 is simply the use of calculator. And let's quickly try the first two.
Okay.
Or no, the first one and last one. One A and D. One is side and the other is angle.
A and D, right?
Yeah.
So I got 11.2.
That's correct. And the
And
angle.
then T. And the last one is 38.8, right?
38.8. Yes. So this is going to be the same. What max is, we will be making the choices, which angle to use, which side to use. And question number 2. Let's try x and the pair. Okay. Try this one. Let me know when you started. I'll follow you.
Okay.
Or I'm just
So
solving.
sine 25 over x equals to sine on opposite of length 6 is the hypotenuse,
Yes.
right?
No, 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 no. Hypotenuse is only in right angle triangles when you have 90 degree.
Oh, so the opposite of angle length is 6. Which one is it?
See, this 120 and 25 lies on the
Oh,
same
so
line.
it's 35, right?
Yes.
Okay. Yeah, so sine 35 over 6. For some reason, I'm getting a low answer. I'm getting 0.040. So, could I
You use
retry?
35 and 6 with
Yep.
x and 25.
So, what I did was sine 35 over 6, and then I times it by sine
Okay,
25.
sine 35 over 6. And then
Sine 25 over x.
sine 25 over x. Now see, you will need to do the cross multiplication.
So 6 with sine 25.
Yes. 6 with sine 25 and x on the other side. X sine 35. Now we make x the subject. 6 sine 25 over sine 35.
Okay. Okay, so it's 4.42, right?
Yes. Now let's try one more. One pair known, one missing, known missing. Let's try the last one again. This one.
$155.04.
Yes, that's correct. Okay. We'll select two parts from each question, and you'll practice remaining as homework. Like in this chapter, there's one more thing left, which is cos rule, and I think there will be a touch of bearing as well. Cos rule, area, yes, cos rule and area. But we need to be fluent and have a strong grip before we start the next concept. Find the size of the angle marked in question number 2. This side was unknown. Now the angle is unknown.
Okay.
Let's try a part first.
Okay. $54.65 or 54.7.
Correct. We solve angles at 1D. Try E part.
Okay. 52.7.
Correct. Okay. In triangle ABC, A is equals to 72, B is this, side is this, calculate. This is more or less the same, but the difference is that we are going to find more unknowns. Let's do calculate size of F and length is. Let's do question number 5.
5, right?
Yeah.
Okay. So the angle is 25, DE is 9.8, and EF is 14.9.
Very good. Question number 7.
So what does it mean by y and z? Does it mean like the sum of both of them?
Yeah, y and z separately.
Y and z
We-
separately.
Triangles.
Okay. But don't we already have to find y
Yes.
in A?
No, that's just the explanation that it must be less than 40.
Okay. But in my explanation, I solved it to say that it was less than.
No, no issues. You just write that that was part B. But in A, you need some words, comforting words to explain. Look at 12 and 15. You'll get that hint. Still not getting it?
I'm thinking.
See, angle 40 is against side 15.
Yes.
And y is against 12.
Yes.
That's less wide.
Oh, so that's why it has to be less than 40.
Yeah.
Okay.
Mm, okay. So suppose we have these like fingers and thumb. And if I just open them up like 2 centimeters, so the first two are 2 centimeters wide. So I'll have an angle X. So when I open them up a little more, say 5 centimeters, so the angle Y is going to be more than X. So the explanation is Y is opposite to shorter side than 15.
That's why it makes it less than 40 degrees.
Yes.
Okay.
Are you getting the same answers for remaining parts, sides and angles?
Uh, I did get I did get 30.9.
Okay.
I'm about to finish Z.
Good.
So do we have to find XY to get Z?
We already have X.
We already have X for S. So do we have to find,
XY side.
yep, length, yep, side.
No, you can find Z directly because you have two angles now.
Oh, we just have to subtract from 180, right?
Yes.
So 109.1. And then side length of XY, right?
Yes.
Okay. So 22.1.
Yes. 22.1 is correct. Okay. Let's try one more. ABCD is a parallelogram with AB is equals to 32, AD is equals to 40, and angle BAC 77. Find the size of angle BCA. BCA to nearest degree. I'm going to solve with you.
Okay. Is it 32.27?
Yes.
Okay.
Remaining answer same. C
Okay.
51.2.
Oh, A, so we got 51.2.
Angle B.
And then B, 51.8. Okay.
Very good. So let's just discuss cost rule. and share homework for sine rule.
Okay.
Now again, it works in pairs. A is with A, like opposite to each other, and then B is with B, and the third one, C is with C. You will face situations when you might also get different letters, but one thing is constant: angle and side, they work in pairs. Now, in this case, one of the formula is already written. Side A, he started off with this side, and if you see, he started off with A, he's using angle A and no other angle. All three sides are being used and one angle. So basically, cos rule is if I start with A square is equals to B square plus C square, remaining 2 minus 2, these two again, B, C, and multiplied with cos of, I started with side A, so this is angle A. Now, if I start with side B, then what does that mean? I'm starting with A or B. Basically, these would be unknown. So if I'm finding B, I'm making that subject. Now I'm writing the other two sides. A square plus C square minus 2, both of these. A, C, cos of B. Now the third side. Try and dictate me that. If we start with C square,
ABC squared equals to A squared plus B squared minus 2AB cos C.
correct. So when we use to the formula, we would see which side is given, which angle is given, and accordingly make subject. Now see if he is like make finding that angle, we might write this formula directly. We may write it this way and then make the subject. The only thing we have to take care is the addition and subtraction is not an issue. Remember that there is a multiplication. So while making
2AB.
subject, students sometimes forget that this was being multiplied. So obviously minus 2ab would be divided on the other side like this. Okay.
Yeah.
And both would work. Cos A is equals to A square minus B square minus C square over minus 2BC. Getting it?
Yes, so it's just rearranging it to get like the angles and everything.
Sorry about that. Can you please repeat?
So it's just about rearranging it to get angles and other parts of the equation.
Yeah. The difference, if we are, you're asking the difference between sine and cos rule. So cos rule is actually when we have very less information given. Like, look at this question right in front of us. We cannot use sine rule because we need to work in pairs. With this angle, side is unknown. With this side, angle is unknown. With 18, the angle is unknown. I do not have any complete pair, so I cannot use sine rule. Getting it?
That wasn't the I wasn't asking a question. I think you heard me wrong. But
So please repeat.
okay. Yeah, I see. So that's what there's only use cost. That's why.
Yeah.
Okay.
So if I'm solving this, he says calculate AC. So now let me say that AC is my side B. So I start off with B. B square is equals to A square plus C square minus 2AC cos of B. Now I'm going to fill up all those values. A is 18 square. C is 9 square minus 2. A was again 18. C was 9. And cos of B. Is it working? The cos button.
No,
Okay,
I
18
don't know
square
why.
minus 9 square minus 2 into
So
18.
for sorry, for homework, you're going to be sending me questions from the sine rule only.
Yes, sine rule, yes.
Could you also send some questions about rearranging the cos rule, if that's possible?
I'll share both. I'll share both. If you like get used to it, you can do both. Or minimum, keep in mind that you have to solve for sine. I
Okay.
just had that in mind that you should be like very comfortable and have a strong grip on sine rule. I'll
Okay.
share sine and cos both.
All of costs or just rearranging?
All of that, solve them comfortably. Till here, I'll share worked examples and these pages as well. Okay.
Okay.
So all this with these solutions and examples and the
Okay.
answers. Okay. So these are our worked examples. Yeah. I was just looking if I missed anything. This is just the simple cost rule. And then we will have one more topic. Any anything you would like to ask?
So for the cosine rule, oh yeah, it's just gonna be use cos and rearranging and
Yeah. For the approach, it should be we will always go for sine rule first. We'll use cos only when it is not possible to
but it's
use.
always sine.
Yeah, sine is easier, that is better, that is quick.
Okay.
There's no negative sign in sine rule. There's no squares, there's no adding up, there's no division. Simple substitution and cross multiplication. Okay, this exercise, we left few questions for practice. You get time?
Yep, it did.
Any confusion in question 3, 4,
Well,
6?
I've only made it to around question 4. I haven't like checked question 5, 6 or the rest.
Okay,
But up
so
to question 4, I have no problems.
okay, you went through these, so you are now good with sine rule. Okay, oh, no problem. 6 just resembles the same question. Let's just try 6 for sine rule. Then we can like just to freshen up, and then we can jump on to cos rule.
Okay.
I'll also do it. I'm done.
Okay, I'm on the last step. Okay, so for QR, I got 7, and then for the size, for the size of P, I got 27.8.
Yeah, I also got 27.8. And when I reached the last line of the question, I read this nearest whole number and then I'm converting them.
Oh,
So I made this
okay.
first change after reading that 32.2 to 32. And then because of this, I got 28 now. So your answer is correct. But I should have read the full question first.
Okay. The 7 is at least correct as well.
Yes. We did question 8 in the last class. And now cost rule. Quick revision and then we'll practice some questions. Capital A, capital B, capital C, which represents the angles, and opposite to that represent the pair which they will work with. So if we start with side A, that's going to involve angle A. A square equals B square plus C square minus 2, both of these, and cos of A. If we start with B, that is going to square both the ends minus 2, both of these, A C cos of B, because we started with side B. If we start with C square, this is B square plus A square minus 2BA cos of C. This is when we are actually finding A, B, or C. And when the angle is unknown, let me use this last one to rearrange. This is C minus B square minus A square is equals to minus 2BA cos C. Now I'm going to divide this. This is C square minus B square minus A square over minus 2BA equals to cos of C. So either we will use this or the first one or this third one. I'm going to absorb this negative sign in the numerator. So this gives me cos C is equals to A square plus B square. Other two are positive. We are starting with C and C is with negative. Divided by 2, B and A, both the other sides. And
So,
then the,
what did
yes,
we do to remove the negative from the negative 2VA?
I took the negative from the denominator and absorbed it in the numerator. Like this, C square minus B square minus A square over minus 2BA. So I took it and minus 1 and minus 1 multiplied and divided the same.
Oh, so giving us A squared plus B squared, and then the last one a negative.
Yes.
Okay.
Let me show you another way of doing this. C square minus B square minus A square is equal to minus 2BA cos C If I start from this step, now see, if I just take that negative sign on the other side and nothing else, so this is going to make it negative c square plus b square plus a square is equals to 2ba cos c. And I'm going to divide with 2ba. The only two mistakes are we forget the negative sign and we forget that 2ba is actually being multiplied with cos c. Students forget that and just bring it on the other side with plus minus. So that's multiplication and division is equals to cos c. I'm personally fluent with these first three. I write them and then rearrange. But
So
both of
this is
these,
just another way of finding angles, right?
yes. And this
Okay.
will be helpful when pairs are missing. Now, see the first question, example question. If I just try to use sine rule, because it says to find AC, if I start with AC over sine B is equals to AB over sine C. Then when I try to fill in some values, AC is unknown. Sine 50 is equals to AB unknown and sine C is unknown. So we fail to use sine rule. Then I need to find AC and I'm trying cos rule and this works in pairs. So I start with this B, that is AC squared is equal to square of other two sides, 9 square plus 18 square, then negative 2 into 9 into 18, and then cos of the paired angle, which is 50. So you see the only unknown now is AC. Everything else is known and we can figure that out. This is the difference between sine rule and cos rule. Still, I'll repeat my words. If we will be able to use both, whenever we are able to use both, we will use sine rule. That is less mistakes, small steps, all positive values. We don't use any negative or 2 or multiply or divide in that.
So because it's easier, we're gonna use the sine rule
Whenever
because
we
it's
can,
quicker to work with. Sorry.
whenever we can, yes. Whenever we have option to use both, we will go for sine rule.
Okay.
Okay, worked example number 19. In DEF, F is equals to 120. EF is given 25. FD is 34. Calculate the side DE. Again, this pair is unknown and I do not have any other known pair. So sine rule fails. To work here, we will go for cos rule. I'm going to find ED. So DE squared is equals to square of other two sides, 25 square plus 34 square minus 2 into 25 into 34 into cos of 120. Is it working? Cos calculator? No, that button.
No, it's not working.
Okay. So let me. Oh, what should we do? That will be a great hassle. Do you have, by any chance, any other calculator at home?
I have calculators, but they're pretty much useless because they're not scientific.
Okay. Okay. Just give it a lucky try. See what cos 120 gives you if it just works. It gives me negative 1 by 2.
Okay. Well, the problem is that I can't, like, when I press on it, it just shows up nothing. It's like I didn't even press on it.
Okay. 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 Now I'm punching every one step, everything in the calculator in one go. 25 square plus 34 square minus 2 multiplied with 25 multiplied with 34 multiplied with cos 120. All of this, and it is giving me 2381. Now DE is equals to square root of 2381, which gives me 48.8 degrees. So DE is, why is this giving us 51.30? 25 square, 34 square. Yeah, I got my mistake. 2AB. I punched 24 rather 34. So that was
Oh,
34, and this is 2631. 2631. And
square
square
root.
of 2631 is 51.29. 293 approximately equal to 51.30 meters. Combining the sine and cosine rules. The following worked example shows how you can combine the sine and cosine rules. Okay, the first fact says calculate PQ before looking at the answer. PQ. Do you think you can do that with sine rule? Finding PQ.
No, because I don't have one of the angles, like the other
But,
two, an extra angle.
yeah. So we'll go with cos rule again. Dictate me, please. PQ squared is equals to.
So PQ squared equals to 5 squared plus 8 squared minus 2, 5, and then 8 times it as well. And then cos P.
Cos of whatever is opposite to PQ. We started with PQ.
So
So,
100.
okay, so now I'm giving you cos 100, and that is negative 0.1736.
Okay.
Negative 0.1736. Okay, now let's find PQ.
Could I redo? Because I got something different.
Yeah, sure. I've also rechecked. I'm getting the same.
I don't know why, but I'm getting a completely different answer.
Okay. What are you punching?
I'm punching 5 squared plus 8 squared minus 2 times
Are
5.
you pressing the equal button meanwhile or just punching all of this?
I'm not pressing the equal button. I'm
What?
punching it all in.
So 5 square plus 8 square minus 2 multiplied with 5 multiplied with 8 and then multiplied with negative 0.1736.
Yes.
Are you sure you're putting that negative sign and multiplication in between?
Yeah.
And you'll have to use a bracket as well.
Sorry?
A bracket as well.
Bracket for negative 0.136.
Yeah, minus 2 into 5 into 8 and into negative 0.1736. If you just use the multiply button, you'll have to use this bracket. Or we can do one thing. We know that negative negative would be positive. So just do 5 square plus 8 square plus 2 into 5 into 8 into 0.1736.
Okay, I'll retry. Okay, I did it all together, but I don't understand why I still got a number that's so much like higher.
Then a square root at the end.
Sorry?
The square root at the end for PQ.
Square root 2.8. Yes. So I was getting the right thing. It's 10.14.
So that gives me a chance to say, to improvise the same thing, that questions are easy. Sometimes student forget to do this, either multiply or negative, and I'm adding it. Forget to do the square root. It's B part. It says calculate to the nearest degree P and Q. Now I have PQ already, and I can write 10.1. Now see, for P and Q, we can also use cos rule. We can also do it by sine. I'll show you both. If I'm looking at P, I say sine P over 5 is equals to sine 100 over 10.1. Is it okay?
Yes. Because it's opposite.
Solving for P. See, what are you getting?
So for P, I get 29.17, so 29.2.
Correct.
And then for Q, let me see.
I'm doing the same with cos or P.
Should I do the same?
Maybe not because of that cos button,
Oh,
but just to show you that we have two methods and see the difference. Sine rule and cos rule. So whenever we get a chance, why do we choose sine rule?
sine rule has less steps, so
As I
it's
said,
easier to do during the exam.
yes, less chance of mistake, less multiplication, division, everything. So we're done with P. That was 29.2, and angle Q would be 180 minus 100 minus 29.2. That is 50.8. And to nearest degree, 50.8 becomes 51. This is 29 and this is 51. Okay, now A part is giving you, is forcing you through question. to learn that formula. Change the subject of the formula. Try this, make cos C the subject, and see if you get the right answer.
Okay. So I got b squared minus a squared minus c squared over negative 2ab.
A and B will have same signs.
If we
So,
move it to the other side,
yeah, if you have B square, it cannot be minus A square.
so plus a and b squared.
Yes. See, you have A square, B square already positive. If you're moving them, both of them will become negative on the other side.
Yes.
So, and what next?
And then 2ab.
Where is
Negative
it?
2ab at the bottom.
Divided by negative 2ab is equals to cos C. Yes, this is one way, and the other is right in the solution part at the bottom of the page. Like he just absorbed that negative sign.
So times it by negative 1 before adding the 2ab.
Yeah, both are acceptable.
Okay.
Or maybe just see that if we make a habit of putting that positive, because that's also an extra step. If we do that in calculator, we'll be we would have to punch negative sign in the denominator. So c square is equals to a square plus b square minus 2ab cos of c. What if we just take this entire thing to left and this to right? So I'm taking that entire thing to left makes it 2ab cos of c, and bringing c here makes me a square plus b square minus c square. And then I divide. Keeping that there, cos c is equals to a square plus b square minus c square over 2ab will also save us from the hassle of absorbing the sign or punching in calculator. Maybe reduce some steps, and definitely this would be easier with numbers. We can keep on simplifying as we move down.
Okay.
Okay, use your answer to part A. Find the smallest angle in the triangle which has sides is 7, 8, and 13. Now, if I just sketch 7, 8, and 13, which angle do you suppose will be the smallest?
It would be the one in the middle of 13 and 8.
Correct. So, opposite to 7. So, if we are talking about this angle, we know this is the paired one. So, if I'm finding this, 7 would be what in A, B, or C?
It would be c.
Correct. So we write other two anywhere, a square plus 13 square minus 7 square over 2 into 8 into 13 and cos of c. So cos of c is equals to calculator 8 square plus 13 square minus 7 square over 2 into 8 into 13. I'm getting 23 by 26 exact form. So cos C equals 23 by 26. Are you getting that? Till this point?
Until that point, 23 by 26.
Okay, and then you just did cos inverse, and I'm getting this angle 27.8 till one decimal place. What should we do with this button thing?
I should get a new calculator.
Yeah, maybe that, and I've actually not opened it, but I've just heard it sometimes that needs cleaning because every hidden button is working, and this same machine would be fine as well.
By cleaning, do you mean like physically?
Yeah, sometimes the dust comes in between the hard plastic and the
Oh, yeah, maybe because this is like a really old calculator. So to clean it, there would just be like,
nail polish remover or any sort of solvent.
okay.
So now we have this exercise. I think we should actually put a small hold to this, and we can start another exercise. That would be very complicated without cost button. All of these are cost rule.
Yeah, so okay.
I'm writing it for myself so I remember why we left that. This is just like obviously practice. And one more thing I would like to mention: wherever there is sine rule, that question is 2 to 3 mark question, and whenever there's a cos rule, that is 4 to 5 mark question. More working, you get more marks. So we can't ignore that you've practiced sine rule and you've mastered it, and we will do this inshallah. Until then, we'll save our time. We'll do this exercise. This involves sine rather than cos.
So is it 4 points if it's mandatory to do the cost, like the cost rule?
That will
Or
be
if you have to choose between two of them, is it still going to be the same point?
no. The question would be placed in such a way that you'll have to use cos,
Okay.
like missing information, and we cannot use sine. And like the question is not only cos rule. We have A part, B part, and C part. So mostly those questions involving cos rule are 1 to 2 points more than sine rule. And the fact you've already seen this more working.
Okay.
Now we're going to use trigonometry and sine to find area of triangle. Now area of triangle used to be 1 by 2 times base times height, and which was pretty straight when it is a right angled triangle. 4, 6. So the area would be 1 by 2 into base into height. So this is 4, 6 times this 24 by 2, 12. Let me say that's centimeters. So this becomes centimeter square. Now what happens if you have triangle which looks like this, that is not right angled, but you know that this height is 15 and this base is 20 centimeters. So you would know area is equals to 1 by 2 into base into height, then you get 150 centimeter square. Either 15 is marked in the position shown or 15 is marked over here. In either way, we know that base and height are perpendicular to each other. Till now, that was basic revision, right?
Yep.
And you remember all that. Now, where is the change coming? The change is here. We have a triangle, and one of the side is 17, the other side is 13. Now, see, no height is given. Rather, we'll be having some angle. For example, we are given with 60 degrees. So in this case, we need to know what this height is. So I can use sine to find this height. If I use sine 60 is equals to perpendicular over hypotenuse. For this only green line, this triangle in red could be used to use sine perpendicular over hypotenuse. Some people have. Remember that?
I remember the sign. No
So
perpendicular over hypotenuse.
yeah, good. So if we are just using these three, we get 13 sine 60 is equals to y. So I'm using calculator and I'm getting, for now I'm writing it in exact form. That is 13 square root 3 by 2. So now I know the height and it would be 1 by 2 into base into height. And this is the area. Now simplifying it in the form of formula, that is always area is equals to 1 over 2 AB sine C. If you look closely, if I say this is going to be side A and this is going to be side B, so that is C. And opposite to C is angle C. So see AB sine C. Formula is AB sine C. When we punch in the values, this is 1 by 2. A is 17, B is 13, and that is sine 60. We'll get exact same answers. 1 by 2 into 17 into 13 square root 3 by 2. I'm getting 95.7.
I'm getting 95. Yep. 0.7 because it's 6.9.
So it always works. The tip is we use the two sides and angle in between them. So area equals 1 by 2 AB sine C or 1 by 2 AC sine B or 1 by 2 BC sine A. So whatever we do, we use the angle in between the two sides. For example, 11, 7, 50. So area is 1 by 2 into 11 into 7 into sine 50. Angle between the two sides.
So this gives us the whole area, right?
Yes. Okay, calculate the area of each of the shape. First one. Area is equals to 1 by 2. Side 1, side 2. Angle in between them is sine 68. There will be two angles to confuse. Are you getting the same answers?
Yes, 22.25, so 22.3. And
And
your B, right? Yep.
okay. 23.2 and 100.9 till one decimal place. Now see, examiner keeps playing with the data. Now he's giving us the area and the angle is unknown. So we just need to punch in things in the right place. Area equals 1 by 2 AB sine C. Area is 20. 1 by 2, the two sides are 8.4, 9.2, and sine C. Let's find that is F. I'm replacing it. So sine F.
So it's 31.171, so 31.2.
Yes. And now we have exercise. And these are exactly the way we will get in exam style questions. So when we look at the first one, this is 1 by 2 into 5 into 6 into sine 42. I'm getting 10.0. If you've done it, that's good, or else come to question number
Yes.
2. We'll leave the remaining for practice. Try question number 2. This is the answer. See what you get.
I know to find the original area of a parallelogram is base times height. So is it still the same like formula for this one? With 1/2 one side plus the other side times the other side
Yes.
times sine 95?
Yes. Now we'll be like doing this because that is a composite shape for us. So we already know that for this one triangle, it's going to be 1/2 into one side into other side into angle in between them. And now we have exactly same.
So
So
times
we
2.
do times 2. So that is one thing. Or you directly write 912 sine 95 and avoid those 1/2 and 2. Both are acceptable. And for now, I would definitely say that show all the working. And once you've done few questions, you'll be able to hold them.
Okay.
Okay, let me see. Third question, fourth question. Let's try question number 4. I'm also doing it. I'll just write the final answer. I want to see if you're getting it. Still ring?
Yes. Oh, I got 42.5.
No issues. That's
Okay.
close. Like what I did is I punched the entire thing for once. So that was area is equals to 1 by 2 into 6.4 into 5.6 into sine 108 plus 1 by 2 into 6 into 8.4 into sine 83. I punched this entire step in one go.
Oh, for me, I separated it into two triangles and then
That would
added them
do
together.
first answer and then the second answer.
Yep.
Okay. Hmm. Try 5B. Still trying.
Yes.
Okay.
So for this one, I tried like separating into different shapes.
Very good.
So at first I tried separating into 4 triangles, but then I realized I didn't know like the inside values. So I did 2 triangles on like each side and
Four
then a
triangles, I
rectangle.
think
Yeah, I don't think that
they've
would
been
work.
like this.
So that's why I just did 2 triangles on the outsides and then a rectangle in the middle. But I still don't know like the inside height, I guess. So how did you do it in one go?
Okay. Not in one go, but that's the final answer. See, if
Mm-hmm.
I just split it into 6 equal triangles, because that's an hexagon.
Mm-hmm.
Now I'm dividing by 360 and I'm getting one of this angle as 60. And when I know that this is 60, that's an hexagon, it gives me 60, 60 again. So basically, one of the triangle, this is 11.2, 11.2, 11.2, and angle is 60. So 1 by 2, first side, second side, sine of 60. This is one triangle, and then there are 6. You get 325.9. That was 9.
Yeah.
This square.
Oh, okay. And then C would be
Okay, let's try to.
8 equal triangles.
Yes.
Okay.
Okay, I think we'll have to take a different approach this time. Hmm.
Sorry, could you go back to where you did like the proportion?
So firstly, we split it into 8 equal parts, and
Yes.
368, I'm getting 45. And as
Yes.
you can see, I've marked X on the diagram. So X plus 45 on the top right corner equals 180, and X is equal to 67.5 because that's an isosceles triangle. Now, when I have X, I've just filled in that value, and 67.5, 67.5, and 45, and 0.6, and one of the side is unknown as labeled as Y. Now I'm using sine rule to find Y. Once I got that, now I have two sides and one angle between them. So area of one of this triangle is 1 by 2 into Y into 0.6 into sine 67.5. Once done, times 8.
So the final answer was
7,
1.738.
8.
Okay.
Okay. Okay, I'll share this exercise and try something to get that cost button fixed.
Mhm.
And then we'll be left with 2 trigonometry in 3 dimension and cos exercise.
Okay.
Okay.
Yep.
Sharing this with you soon, and I'll share this like this original one with the working, so you have to do the remaining parts.
So up to, you're going to also do your 15.12?
Yeah, 15.12. That cos one is on hold.
Yep.
Anything you would like to ask for now?
No.
Okay. See you soon in next class. Do you have like a working calculator with cos button?
Yeah, I do.
Very good. So cos rule was a square is equals to b square plus c square minus 2bc cos of a, and for angle cos of a is equals to b square plus c square minus a square over 2bc cos of a. General formulas. We've almost done sine rule and area. We
Yes.
just go through some questions of cos rule.
Oh, before we begin, I have some questions from the homework.
Sure.
So from 15.10 on 8C, I kept trying to get the right answer, but the book's answer for the question was 34.26, and my answer always was 34.35, even though I redid the question a lot of times. So I don't know what I did wrong.
This exercise 15.10.
Yeah.
And question number is
8C.
8C. I'm getting 32.27. We did this in the last class.
Oh, because I didn't see it on the paper. But when I did it, I got 34.35. So
Yeah, make sure you're not switching these. Like 51.8 is on this side and 51.2 is on the other side. Find the size of BCA. So when we are finding the size of BCA, this is 51.2. And then when you subtract both of these, you get this as 51.8. And then we are finding the side AC, This is unknown. So this pair, and we have another pair. Do it now quickly. 32 divided by sine 51.2 and then multiply with sine 51.8. See if you get the same answer.
So I got 32.27. But for my values were different. So instead of 51.8, I had 52. And instead of 51.2, I had 51. Because I wanted to cancel out the decimals.
Yours is correct. Says find the size of the angle BCA to nearest degree. So to
And
nearest degree,
yep.
that is 51, yes. And then you'll have this as 52.
When I did it that way, however, I still got 34.35.
I'll quickly check. This is
Okay.
32 by sine 51 times sine 52. I'm getting 32.447. With these values, 32.447. And what is the answer at the back?
It's 34.26.
34.26.
Yep.
That's a lot of difference. Oh, that's 32.26, not 34.
That's fine.
So your answer is correct, 32.26.
No, for my answer, I didn't get 32.26. I got 34. I wrote 35, but I'm checking my notebook.
No,
And I
but
wrote,
you're getting 32 now.
yeah, right now, 32.45.
Yeah. So that's correct.
So it can be either or, right?
No, like it cannot be 34. It could be 32.26, 32.27, 32.44. It could be anything between these, like 32.26 to 32.44. It could be between these two, just because of this rounding, 51.2 and 51.8. But it cannot be 34 point something.
Okay. And then I had another question for exercise 5.12, 6B.
Well, 12, this is 5, 6B. Okay. The diagonals of a parallelogram bisect each other at an angle of 42 degrees. If the diagonals are 26 and 20 centimeter long, find the area of the parallelogram, the length of the sides.
So for this question, I first drew out the parallelogram in like a rough way, just so I could have like a general idea of it.
So we have this parallelogram and one of the diagonal is 26 and the other is 20. And when it says 42, obviously this is the one acute. This 42, the other is obtuse.
Yep,
So
138.
138, the area.
No, the other area. I mean, the other part.
So this is going to be 13 and 10.
Yep.
So area of this one triangle is going to be 1 by 2 A into B into sine 42. And what I'm going to do is times 4 for the complete parallelogram.
Yep.
Because 13 and 10 are not changing, and either it is sine 42 or sine 138, that gives us the same value.
Yeah, I did the same thing for the area.
So times 4, I'm getting 173.97. 173.97, approximately equal to 174 centimeter squared. B part says the length of the sides.
Yeah, this was where I was wrong because I did it as like the smaller sides is 9.3 and the longer side is 18.7.
Okay, I'm going to use cos rule.
Okay.
So this is x square is equals to 10 square plus 13 square minus 2 into 10 into 13 into cos of 42. 10 square plus 13 square minus 2 into 10 into 13 into cos of 42. 75.78, and square root of the answer is 8.705. Approximately equal to 8.7 centimeters. And for the other side, everything stays the same, but the angle changes.
Oh, for
So
this one, oh, I think I know what I did wrong. So you used 42, but I used the other two angles, so I used 69 instead of 42.
you have to go in pairs. Angle and side should be in front of each other.
Sorry, angle and...
Angle and opposite side should be in front of each other. They
Oh,
always be in
yeah.
pairs.
Okay.
So 138, I'm getting 462, and square root of that is 21.499. 21.499, approximately equal to 21.5 centimeters. Clear?
Yeah. I don't have any more questions.
So you've already practiced cos questions.
Yes.
Okay. So after those cos questions, we can move on to next exercise. We've already covered the area part and 3Ds left. Let me just have a quick look. Area's done. And we are not holding this anymore. Okay, now we just have to have a strong imagination, both when we read the question and when we look at the diagram. For example, in whichever room you're sitting, how many edges are there? I'm sorry, you should consider that a cubicle room.
Yeah.
Maybe you would have designs. So edges, corners, and planes. So how many planes are there, how many corners, and how many edges? Can you count them?
I have 12.
12 edges.
Yep.
And corners?
8.
8 corners. And planes?
6.
6 planes. Very good. So there's no doubt in what it is: edges, corners, and planes. We will be dealing mostly with edges and corners. Now, if I tell you that you have a certain space whose dimensions are given as 4, 2, and 3. So these are the dimensions, and I ask you to find the greatest distance between any two corners. So obviously, that is not going to be this. That would be one at the lower left end, the other at the top right end. There are few other options as well, but they'll give you same answers. Like if I choose this right corner and I choose this top corner, they will again give me same value. So now we have to imagine how we can find this greatest distance. I'm labeling them for easy communication: A, B, C, D, E, F, G, and last one H. Now I can see through it that AD is the longest line. Do you agree?
Yes.
So when I find AD, I'm first going to find AC. When I look at AC, I see that AC squared is equal to 4 square plus 2 square. And AC squared would be square root 4 square plus 2 square, both sides. AC is square root 4 square plus 2 square. If I would have written XYZ instead of 4, 2, and 3, X, Y, and Z, so AC would be clearly X square plus Y square whole square root. Any doubt?
No.
Simple Pythagoras theorem. Now I'm going to find AD. So when I find AD, I know I'm dealing with AC and CD. So this would be AC squared plus CD squared whole square root. So AC is right on top of it, which was X square plus Y square square root whole square plus Z square and this. So when I simplify, I get X square plus Y square plus Z square. So I'm going to get AD as 4 square plus 2 square plus 3 square whole square root. Clear?
So that's the simplified version.
Yes.
Okay.
We can also do it step by step, but we've done it in two ways: by writing the variables and by writing the numbers. And now we know this always works. So whenever we have a 3D shape, we can directly use the 3 dimensions to find this. If someone will tell me that find the distance between B and this new point Y, BY, I would just use these 3 dimensions. I would write BY is equals to one dimension is 4 to get there. The other dimension is this halfway, which is 1 now. Are you getting it? How this is 1?
Yep.
If y is in between these two, so that is 1 square plus when I go up, that is 3. So that saves my time. We can practice this. We
So
can
with
have
any 3 values, we just square them all and then we put them in a square root.
yes, length,
Okay.
width, height, if they are at right angles to each other. Length, width, and height. If they are at right angles to each other, this always works.
Okay.
Okay, so trigonometry in 3 dimensions. This might seem a little funny because the question says in 3 dimensions, and you will see this diagram as well drawn in 3D, but we are always solving them and always applying formulas of 2D. Coming back, when I was solving for AB, that is one dimension, only 4. When I was solving for AC, I was applying Pythagoras theorem using 4 and 2 only. When I am solving ABC, that is just a plane, 2 dimension, because I'm not looking at F, G, D, and E, and Y, and even H. When we are solving AD, we're looking at ADC. Again, AC is a straight line and D lies vertically above C. That is a single plane. We can apply simple Pythagoras theorem. We can apply simple sine cos tan. We can apply sine rule. We can apply cos rule. All those same formulas, because we just extract our required information, extract our required shape, and we solve it. We just have to have a good knowledge of 3D shapes and understanding what they're asking. We'll go through a few examples. They always say this is 3D, but we just extract our required shape. Worked example says the diagram represents, let me just zoom in. The diagram represents a room which has a shape of cuboid. AB is equals to 6, AD is equals to 4, AP is equals to 2. So length is given, width is given, height is given. Calculate the angle between the diagonals BS and the floor ABCD. I'm
So when
looking
it
at,
means floor,
yeah,
does it mean just like the outside length, like the perimeter?
angle between the floor, that is the plane. If you just rest your pencil on your table and then you lift one end and keep the other end on the table, this is the angle between your table and pencil. So if I just consider this line BS, this is my pencil touching the table at D. So I'm going to find the angle between the table and the pencil. See, this is the rubber end. This is the tip of your pencil. And it is, the rubber end is touching the table. Now, obviously, the angle would be right below it, not this point.
Yeah.
This point. So whenever I'm looking at that pencil, I'm looking at this way. Whenever I'm looking at the table, I'm looking at this way. So this is 2D for me. I just have to understand that I'm looking at these and not these extra spaces, because this is not the angle under the table and pencil. This
But
is
what
the one.
does it mean for ABCD?
A, B, C, D. No, that is the plane. So I will now extract my required data to find that angle. Do you agree that DBS is that angle? DBS is the angle between BS and the plane.
Yes.
So see, I've just extracted my required diagram. DS is already 2. DB is unknown. I can find that because we know 4 and 6. So there goes BD squared is equals to 6 square plus 4 square. BD is equals to square root 6 square plus 4 square. And I'm using it, square root 6 square plus 4 square is giving me 2 square root 13. For now, I'm keeping it in exact form, which is 7.211. Okay, or let's just use that. Makes more sense. 7.2.
Okay.
Now this is BD and DS is already 2. I can find this angle. That is tan of B is equals to 2 over 7.211, and B is equals to tan inverse 2 over 7.211. Shift tan 2 divided by 7.211. I'm getting 15.5 degrees.
15.5.
Now this question may have B and C parts or whatsoever, but every time whatever we are solving, we'll be dealing with 2 dimensions.
So ABCD is just the triangle that we've drawn?
Yes.
So we're just going to draw that as an answer, right?
Whenever we draw it, it is never the part of solution, but that is good for us. We avoid silly mistakes.
Okay.
Like if I just erase the diagram and leave the working there, that's enough for the examiner. But I always extract what I'm working on to avoid silly mistakes, because these might score me 3 marks.
Okay.
Now, if I say that we are doing calculations on the room which you're sitting in, and they tell you to find the distance between bottom left corner of the wall in front of you and top right corner. We started with the room, that is 3D, but I'm finding distance between 2 points. I can do that with two dimensions. I just need the width of the room and height of the room and apply Pythagoras theorem. The next question, if I ask you the angle between that line and the floor, again you can apply tan, or you can apply sine cos as well, because now you have all 3 dimensions. Getting it?
Yep.
Okay. The diagram represents, now just by a glance, yes, that's a 3D shape. Now, when we will go in detail, you will see that it becomes 2D because we extract our required information. The diagram represents a triangular prism. The rectangular base ABCD is horizontal. AB is 20. I can see that. BC 15. Got it. The cross section of the prism BCE, this cross section, is right angled at C. I was interested in this, so I should know I can apply sine cos tan. If it is not right angled, I'll be going for sine rule or cos rule. Then it says EBC is 41, noted. Now I have to find. So the length of AC, I need to find this length AC. Okay, I'm extracting everything. This might seem a little lengthy, but that is not required. This is our start. Maybe after second question, we're not doing it. So just for understanding, I can see this is AC, and I can see that this is B, and it is right angled at B. This is 20, that is 15. No need to make it every time, because you can just figure out that you're going to use this triangle. And that is 90° at B. Any doubt that it is 90 at B?
No.
Good. So we're finding AC, and which is 20 square plus 15 square whole square root. See, Pythagoras theorem is applied on 2D. Sine cos tan is applied on 2D. Sine rule cos rule is applied on 2D. So 3D is thus the shape, and we extract what is needed. B part. Calculate the length of EC. This is EC. Can we use this triangle to find EC?
So BC is 15
Yes.
and 20. So yeah, we can use the angle and the triangle.
Yes. So I'm using tan of 41 is equals to EC over 15. So this is 13.039. I'm writing 13.0. EC is equals to 13.0 centimeters. C part says calculate the angle which the line AE. So let me erase that. And AE makes with the horizontal. So now I'm looking at ACE. Angle EAC is what examiner is asking. Any doubt?
No.
This was already 25. This was already 13. And do always write the unknowns which you've already found. So I can find this angle using tan again. So tan of this is equals to 13 by 25, and EAC, angle with the horizontal, is tan inverse 13 by 25. And I'm getting 27.5 up to 1 decimal place.
So we just did tan of EAC to get the angle.
Yes.
Okay.
The examiner was asking about this angle. Out of this 3D shape, we just have to see which lines we need. Once extracted, it is all 2D.
Okay.
Okay, now let's try this together. The cube shown in the diagram has sides 5. All 5 use Pythagoras theorem to calculate distance EG. And leave it in exact form, no decimals.
7.01. No.
Better no decimals.
Exact form, so 5 square root 2 outside 5.
That's correct. This is 5 square root 2. B part says use Pythagoras theorem to calculate the distance AG. Leave your answer in exact form.
So it's just basically square root 5 squared plus 5 squared plus 5 squared.
Yes. That is giving me 5 square root 3. Now, step by step, this B part is actually what we discussed earlier, A square plus B square plus C square. No one can like challenge you, you can use it. But the examiner was expecting that one would use these two sides to apply Pythagoras theorem, like 5 square root 2 squared plus 5 squared and 10 square root. So we still get same answers. Any doubt?
No. But it's still like correct if we use like the other method,
Yes.
right?
Both are correct. Both are acceptable. That is just the one on the left. A square plus B square plus C square is sometimes difficult when you are teaching a group of like 22 students. Some would catch that, some would take some time. This is
Okay.
actually one-on-one, and I can like clearly hear you out if you're understanding.
Yep.
If I would be teaching the same topic in group, I would never touch this.
Okay.
And maybe after 2 to 3 days, one of the student is telling me that this is also one way because he's practicing this, and then she knows that this could be done in second method as well.
So some would know, some wouldn't.
Yes, and both would succeed. Basically, if we go deeper in this discussion, we are having 100-mark paper. We are having a fixed time. No one can score 150 out of 100. Either you get full or you get less than that. So if we are fulfilling the requirement, everyone is understanding the topic, everyone is getting the answers correct. At this level, that is okay. Now, those students who go an extra mile, who want to appear for some competitions, some extra tests, some higher universities, definitely they go out of box. They also think themselves. And yes, they can always ask the teacher that is there anything else I need to know. So these are those methods. And by the way, this is also used in SAT because SAT is battle against time. Topics are not that hard. It is battle against time.
And also, I won't be doing the SAT. I'll be doing the SSAT for upper level. Because the SAT, I'm doing that in 2 years.
Yeah, no issues.
Yeah.
Basically, you're currently in grade 8,
Yeah.
right? What we
Yes.
are studying right now is grade 10 and 11 in some schools. It is grade 9 and 10 in some schools. Basically, in some schools, they do IGCSE in 10 and 11, and some do in 9 and 10. Both pass out. That is the final year. So I would say that after doing this 15th chapter, you are at this level. So somehow, you are mentally at that stage that you can also attempt SAT.
Okay. But the SSAT and SAT are like the upper level SSAT and the SAT, I think they're basically almost identical. But the SSAT may be a little bit easier.
There are actually, if I would categorize these are 4 levels. 1, 2, 3, 4. I forgot these exact numbers, but this is still grade 8. I think 5 to 8. This is 1, 2, 3, and this is 4. Maybe 6 and 4, 5 something. Not exact. So this is junior, middle, and upper. So if you are going to change your school or something and to enter grade 9, you would need upper SSAT. And SAT is after your A levels or after your high school for uni.
Yeah.
And trust me, SSAT is a bit hard than SAT. SAT is easier.
Oh, but
Because
isn't the age group for the other one easier? I mean, like
no, no,
lower?
see, SSAT is not going to work in Pakistan. It is not going to work in India or China. It is not going to work in Germany. SAT is universal worldwide. So it has to be generic. Someone coming from Pakistan, someone coming from Canada, someone coming from Afghanistan, someone coming from Australia should be able to attempt that test. Are you getting the point?
So it's
If
made easier for everybody to be able to do it.
yes, so one thing region, the other thing study board, the third thing board syllabus. One is coming from a metric and FSC background, one is coming from Cambridge background, one is coming from federal board. Different boards, different education, different sectors. So there has to be an overlap. So minimum 80 to 85% SAT is generic. And then the remaining 50%, 15% is that what you practice for. That is why it is easier. SSAT is in those countries who are training their students since grade 1. Like if I have to take admission in class 1, 2, 3, 4, 5, 6, 7, 8 in Pakistan, I do not need SSAT. I just need to pass 3 subjects, that is English, mathematics, and Urdu test, based on which class I'm getting an admission for. If you're targeting grade 8, you will attempt test for grade 7. You pass that, you got admission in grade 8. So that's a different criteria according to the country and according to the board. That is why SAT and SAT has a lesser syllabus than SSAT. Actually, this was something I wanted to know, that whatever we are targeting for, we will go for. Maybe for SSAT, if we do that, maybe we are going to study 60 small topics. And for SAT, we'll be studying 35 to 40 topics.
So is the material for SAT though harder, or is it still like easier?
The higher you go, it gets easier.
Because of already the practice from before?
Because it is generic.
And SSAT has a lot of. Okay.
It would, you can say that it would include 90% of what you studied or throughout your life. SAT would be less than that. Syllabus would be less than that. And also like calculator and non-calculator sections. SAT is now completely calculator.
And it also has like an English side as well.
Yes, English and math both. That is SAT 1. SAT 2 used to be compulsory in some universities, but not anymore. One just goes for that if he wants to stand out, make his application a bit different than other. For example, some students go for 8 subjects, some go for 12 subjects in IGCSE. But minimum is what is compulsory. Extra is one opts for. That's a personal choice.
So there's supposed to be subject exams for the IGCSE, right?
Yes.
And students, there's the GCSE, which is done in England. And do they usually do the exam in 10th grade or do they do it in 11th grade?
Mostly 10th.
Okay.
But both options are there.
Yep.
C part. Calculate the angle between the line AG and the plane EFGH. So which angle are we going to find? We have all the letters mentioned.
G?
Yes. But what G? CGH, CGF, CGE, DGH, AGH. See, you already said G. Yes, that is it. But
AGE?
which AGE? Yes. So you extracted the correct triangle AGE. May I know which lens are we going to use to find this?
We're going to use us. Wait, what do you mean by lengths? Do you mean like
Like I'm going to find that angle, so I need to know which lens I'm using so I can decide sine, cos, or tan.
oh we can use 5 square root 2 and 5 square root 3. We can use cos.
Very good. So cos of G is 5 square root 2 over 5 square root 3. Shift cos of square root 2 by square root 3. I'm getting 35.3. Because we had all three sides, we could use any sine, cos, or tan.
Yep, 35.3.
Question number 3. The diagram shows a tetrahedron A, B, C, D. Okay, whatever name is given, I'm never interested in these fancy names because I'll be extracting just my lines and angles. M is the midpoint of CD. While we read the sentence, also look at the diagram. AB is equals to 4, AC is equals to 3, and AD is equals to 3. Okay, and now I know the lines, I know the center point, I know the angle at A is the right angle in all sides. I'm going to calculate angle ACB. See, out of this 3D shape, we've already extracted while reading that which two-dimensional side I'm going to use. So this is tan of C is equals to 4 by 3. C is equals to tan inverse 4 by 3. I'm getting 53.1.
Yep.
B part says calculate BC. I think without discussion or thinking, you would have thought Pythagoras theorem.
Yeah. So square root 4 squared plus 3 squared.
Correct. Calculate CD. Did you figure out which sides we are going to use for CD?
For CD, we'll do 3 and 3, so square root 3 squared plus 3 squared.
B part. Calculate the length of BM. Now see, that's B and this is M. It is actually overlapping on A as well. So for my ease, every student would have different level of understanding. For my ease, I'm extracting it. This is B, right above A, and this is M. And when I have to find length BM, I already know BA is 4. I just figured out that there's one other, like there were two sides, two unknown sides. I knew BA, which was 4. This was unknown, this was unknown, right? MA
Yep.
is also unknown. So I just dropped that idea and I'm going for a different triangle, that is this one slanting, this slanting one. So BM, this is B, this is M. 2 right is actually half of that, 3 square root 2. So I'm writing 1.5 square root 2. And we already have BC, which is 5. And this is 90. Does it make sense?
So you just did the slanting one?
Yep.
Okay.
BM is also slanting. BC is also slanting with respect to the 3D shape. But when we extract this triangle, it is right angled at M. BMC is right angled, so we can use Pythagoras theorem, which is 5 square minus 1.5 square root 2 squared whole square root. And I'm getting square root 82 by 2. 4.53 meters. Last one says calculate BCD angle. Now, do you agree that BCD is also equal to BCM?
Yes. Because the
So
angle doesn't change.
angle is not changing. Good. So I'm finding BCM, like I'm using those lengths. I'm using cos. But I'm writing BCD. Cos BCD is equals to base over hypotenuse. So base is 1.5 square root 2 and hypotenuse is 5. So BCD equals to shift cos of 1.5 square root 2 over 5 is 64.895. So that's 64.9 degrees. Clear?
Yep.
Okay. Try question number 4.
So A is equal to 14.9.
14.9, correct.
B is equal to 15.2.
Correct.
So C is 11.4.
Very good. Excellent. A, B, C, D is a tetrahedral rings cartoon. And now we need to know what this is. Tetra is 4. These are 4 triangles joined together. Whenever it is not clear, we cannot see anything. This is the top point, and I have triangle at the base. And this could be it one way. The other could be that this top point is actually vertically above one of the points. That would make all these 3 as right angles. So tetrahedral is 4 triangles joined together. Triangle ABC is the base, B is right angled. So A, B, C, right angled. D is vertically above A. So this is the one. Calculate the following in terms of the appropriate lettered sides, the length of AC. ABCD is a tetrahedral cartoon. Triangle ABC is the base, B is right angle, D is vertically above A. Calculate the following in terms of appropriate lettered sides, length of AC. Okay. So there's no length given. We are going to keep it generic. AC, if I'm going to find AC,
It's
that will be
AB and AB squared plus BC squared square root.
correct. DA,
It's square root BD squared and AB squared.
BD squared and AB squared, correct. DC,
It's square root BC squared plus BD squared.
correct. Angle DAB,
It's BD over AB. Tan inverse D DB over AB.
correct. BDC,
It's BC. Tan inverse BC over BD.
last one. The size of angle ADC,
It's AC over, tan inverse AC over,
we cannot use tan if you are using ADC.
sorry, ABC.
If you are using A BC, we cannot use tan because these are not right angles.
So we can use cos rule.
Yes, excellent. So angle at D, we're starting off with D. So that's cos of D is equals to, opposite side is AC, so that needs to be negative. And now we can complete our set. AC is done. The other two sides are AD squared plus DC squared divided by 2 into AD into DC. I wrote this. I took the lead because at this stage, I'm not expecting that you memorized it. While you will be solving the questions, you will be comfortable with it. For example, cos of A is negative A square plus C. Is it?
Sorry, you froze from cos of A.
Once you just start writing that. Okay, I was just trying to help you memorize it. Like when we start from cos of A, you write negative A square and then you fill the remaining letters B square plus C square and 2BC. When you start off with B, you write negative B square and then
A
you fill in
squared
the remaining letters A
C
square
squared.
plus C square to AC. So when we just do number of questions, you'll get used to it.
Okay.
And we finished the entire chapter. I'll use some other source and share some questions, but let me just show you some questions from past papers. Okay. Is it visible?
Yep.
A, B, C, and D are 4 points on level ground. BDC is a straight line. All these 4 points are on ground. BDC is a straight line. AD is 30. DC is 64. Angle at B is 37. Angle at D is 58. Calculate AB. What would you use to calculate AB?
I can use
We're calculating AB. So that's a question mark. Maybe this is now helpful to focus.
because we don't have the length of the base either, so
Right? Whenever you're stuck, like just now, this hypotenuse square is equal to base square plus perpendicular square. And we for sure know we cannot use this. Why so?
because we don't have the base or the
Well, say it,
the-
say it.
sorry,
Right angle.
and we don't have a right angle.
So this is not a right angle triangle, so we cannot use sine, cos, or tan. We cannot use these four. What are we left with? He's not
Possible.
asking about the area. 1 by 2 AB sine C. He's not asking about the area. So we're left with either sine rule or cos rule.
I think sine rule.
Sine rule. So AB over sine 58 is equals to
30 over sine 37.
30 over sine 37. And then use of machine. 30 over sine 37 into sine 58. And I'm getting 42.3.
42.3, right?
Calculate AC. See those points. First question was 3 points. Second is 4 points. What does that hint give you?
That we have to do 3 things.
Yeah.
And for B, we have to do 4 things.
We discussed. One more thing we discussed. Cos rule is always lengthy. Now,
Oh,
whatever you try, you will not be able to use sine rule because of the missing information. So, how do we find AC?
so that we have to use cos rule.
Yes. And what dimensions? We start off with AC is equals to 30 square
Plus 64 squared minus, 230.
and cos of what should I write? This is 120.
122.
In case of sine, sine 58 is equals to sine 122, but cos is not equal because one is positive, the other is negative. So always be careful with this one. And now use your calculator to find AC.
Yeah. 7,030.9
Correct.
or 7,031.
Correct. Next step, taking square root.
Wait, sorry.
Yeah, that's correct. That's correct. Next step is take square root.
Okay. And then ADC.
And then calculate area of ADC.
Oh, we can do 1/2 30 times 64 and then sine 122.
And sine 122. That's correct. Okay. 6. Second, I forgot that was master copy, or it would get permanent. Okay. Let's try this question. This was topic 22. Copy. Paste. Try this question. Did you get the angle BAE?
No, not yet. $68.8.
68.7. Next one is 49. 68.749. So it rounds up to 68.7.
Oh, for me, I got 68.751.
Why are we getting different? That's tan inverse 18 by 7.
Yes.
I'm getting 68.74949.
Okay, should I try again?
Yeah, do that. So I also get it.
Okay, now it's 749. So 68.7.
Second, the area of trapezium ABCD. Do you know the formula for trapezium?
Yes, it's 1/2 side 1 plus side 2 times height.
Correct.
I know everything else. I'm just trying to get like the base of the. I'm trying to get ED.
Yeah. Area is going to be 1 over 2, side 1 plus side 2 times height. Whatever we know, let's write that. Let's say this is 9 and leaving us 2, and the height is 18. So when you look at ED, now just think over ED, nothing else. How do you get this ED?
Maybe 10. So 1055 equals to 8 over x. Um, Open 6. And then plus the 7. Yeah, 19.6. So 1/2 9 plus 18.6 times 18. Yeah, 257.4.
PQRS is another trapezium. PQR is 112. PRS is 41. Each match it correct to nearest degree. Okay, this is a different topic, but let's just finish it. Find the smallest possible value of QRP. QRP, this angle. Now we know this is 41. This has to be 41 vertically opposite, alternate angles. And if I have to find the smallest possible value of QRP, the other two need to be largest. So they are measured correct to the nearest degree. Correct to nearest degree, this could be 112.5. This could be 41.5. So this is going to be 180 minus 41.5 minus 112.5 to give QRP the smallest possible value. And that's 26. This was from limits. I will share this sheet with you along with answers. So these are a mixture of all of basic and advanced trigonometry and bearing.
This is a past paper, right?
Yes.
For
This is,
IGCSE?
yeah, this is from GCE.
Oh, GC, okay.
This is an overlap.
Okay.
Exactly same in both books. Anything you would like to ask?
No.
Sending it shortly in few minutes. Question number 1.
1D.
D part. Okay. The vertical tower stands at A. P is the point on line BC. Tower stands at A. P is the point on line BC. Okay, this is A. This is BC. P is somewhere on BC. And it says that the angle of depression from the top of the tower to line BC is greatest. Now, the angle of elevation or depression is always greatest from the closest point. For example, someone is standing at this position and they are looking at this point A. So when they come closer to it, they have to look more higher. Angle becomes more when they move closer. So angle of elevation or depression is the greatest when it is the most closest. So point P is on line BC. So that is supposed to be somewhere which is the closest point that makes it 90 degree. And this is P. Closest point is always perpendicular. And something is standing vertical at A. Now this diagram is not actually 3D. So I will extract my required triangles once I know what I have to find. So it says given that the angle of depression is 34, calculate the height of the tower. So I need to find this height of tower. Let's say that this is point A and this is the tower that is standing. Let me say this is T and from P. So PAT and the angle given is 34. I have to find the height which is unknown. So if I know PA, my question is solved. Now I'm going back. To find PA, I can use this triangle. I can use BA and BP and 37. And we had few sides. AC is AB. Oh, yeah. AB in the first part. Can you please share your answer for AB?
Okay. Sorry. Okay, for AB, it was 42.3.
42.3. So AB is 42.3. Now I'm using this 42.3 to find BP using cos. So cos of 37 is equals to BP over 42.3 using calculator. 42.3 into cos of 37 is 33.8. So BP is 30. BP, yes. Sorry, why I'm doing that? I need to find PA. So I'll be using sine. I'm finding PA. Sine 37 is equals to PA over 42.3. So this is 25.5. PA is equals to 25.5 meters. Now we can use tan. Tan of 34 is equals to height over 25.5. So we're getting 17.2 meters. Clear?
So tan of 25.5 and tan 34. I'm trying to do these with you, and you said the answer for that was 17. Okay, 17.2. Can I quickly redo that equation?
Yeah,
Because
yeah, sure,
just
sure,
that equation, just that part, because I got 14.
sure, sure.
Okay, 17.2. Okay. And then I had another question for question 4A.
4A. Okay. The diagram shows the position PQRS. PQRS of 4 hotels. The bearing of Q from P is 0.65. The bearing of R from Q is 210. PQ is 500. SQ is 335. PQS is 90, and calculate PQR. Okay. Okay. PQR. Now see this complete angle and this 65. Sum of these two is 180. Why? Because they are between parallel lines. 180 minus 65, the complete angle marked is 115. Now I'm taking out 90, or I'll do that in the next step. Now I have this 115 and 210. So this remaining PQR is equals to 360 minus 115 and 210, which gives me 35.
And then, okay. And then another question for 4C.
For C, calculate the bearing of S from P. And the previous part was P to QR. Okay, that's different. Bearing of S from P. So we need to find this angle.
So that's half of 65.
No, in that case, he would have said that it is a bisector.
Oh, okay.
Now see that 115. I'm taking out that 90 to find the upper half, which is 25. This section only is 25. Now this 25 could land here as alternate angle. And before that, just to avoid some mess, I'm going to find this complete angle. And I'm using tan. Tan of S is equals to 500 by 335. So PSQ is equals to shift tan 500 divided by 335 is 56.2. Now this angle is 56.2 degrees. So if I draw this north here, this 25 comes here as alternate. Now 56.2 minus 25 will give me the other side. 56.2 minus 25 is 31.2. So this side is 31.2, and now these two are alternate. 31.2. So bearing is 031.2 degrees.
Okay, thank you. And then I had another question for 6AI.
Okay. Okay. In the triangle ABC, ABC is equals to 45, BAC is 65, AC is 5 centimeters shorter than BC. Whatever is BC, AC is 5 centimeters shorter. Show that BC is equals to this. So let me try this pair. BC over sine 65 is equals to AC over sine 45. So BC over sine 65 is equals to, now I'm writing AC as BC minus 5 over sine 45. Now we do the cross multiplication and make BC the subject. This is BC into sine 45. On the other side, BC sine 65 and minus 5 into sine 65. Meanwhile, when I'm doing this, I'm also having a look at the question to know which shape I have to make. And I'm taking BC sine 65 on the left hand side. BC sine 45. No, I'm bringing it on right hand side. That would save me one step. BC sine 65 is already there. Minus BC sine 45, and meanwhile this 5 sine 65 goes on the other side. Now see, I'm going to take this BC out as common and divide the other thing on the other side. 5 sine 65 is equals to BC common, sine 65 minus sine 45, and shown 5 sine 65 divided by sine 65 minus sine 45.
Okay. And then I think I have another question for, 6C.
Okay. The triangle DEG has the same area as DEF. Okay. So DEG is somewhere else, has the same area as DEF, but is not congruent to triangle DEF. The point G is lower than DE, and the GE is equals to EF. So EF and GE are equal. If I will make it this way, this is going to be congruent. So this is not acceptable. But there's only one way if I can keep these two equal is suppose I draw this circle. So G point has to be on the circle somewhere, right?
Yes.
So if I make it here to make EG equal to F, definitely it is not going to have same area because now the base ED is same but the height is less. So there's only one way, that is I take this on the other side, make it equal in length and this. So these two lengths are equal and this is equal. So 1 by 2 AB sine C, whatever angle is this, this is the other half. If this is theta, this is 180 minus theta. Now it says draw the triangle DEG in the diagram above. Done.
So, but since the height is longer, or is it longer?
No. Remember that 1 by 2 AB sine C. Let's say this is A, and let's say this ED is B. AB and sine C. Done. Area for the first triangle. And for the second one is 1 by 2 AB sine C. See, this A is equal to this A because EF is equal to EG. And we have a common side B. And sine of 180 minus theta is actually equal to sine theta.
Okay. I see. Okay. That was my last question.
I shared 6 questions. I think we should give some more time to this topic. This is a like more scoring topic and we need more practice.
Yes.
Two boats sail from point A. One boat sails to B and the other boat sails to C. AB is 8 kilometers, AC is 6 kilometers, BAC is 115. Calculate the distance BC between the boats. How do we calculate this distance?
We have to use the 8 and the 6.
We have to use 8 and 6, so sine rule or cos rule?
So it can be, it has to be the cos rule.
It has to be the cos rule. Because for sine, we need pair, either two angles or two sides. One side is already missing. So we are going for cos rule. BC squared is equals to 8 square plus 6 square minus 2 into 8 into 6 into cos of 115. PC is equals to square root of whatever we'll get. 8 square plus 6 square minus 2 into 8 into 6 into cos of 115. That is 140, and square root of answer is 11.85. I'm writing 11.9. Second part says the bearing of B from A is 200. That means this complete section is 200. So 200 minus 115 is giving me 85. This upper half is 85. Okay, now it says find the bearing of A from C. So I'm sitting at C and I have to move clockwise all the way to reach this point. So you see this 85? And we are going to get this 85 on the other side as alternate. You see this north line, you see this AC and this. So this is 85. So I have this 180 plus 85. 265. Bearing of A from C. B part. In triangle PQS, SQP is 44, SQP is 65, and QSP is 44. R is the point on QS such that QS is equals to QR is equals to 200 and RPS is 36. In triangle PQR, by using sine rule, show that PR is, so this PR is unknown. Okay. So if we are looking for this PR, this has to be PR over sine 65. No issues in this. This is a complete pair. Now you can see this 200. So I must know that angle. On the other side, it is 200 over sine of that angle RPQ. I'm going to find that angle. We subtract these two from 180. 180 minus 36 minus 44. I'm getting 100. So this is 100. The opposite side is 80. Now we subtract these two from 180 to get this. I'm getting 35. So my next pair is 235. Now sine 65 cross multiply PR is equals to 200 sine 65 over sine 35. Second part says hence show that SR is equals to this. So I'm making that pair for SR. Looking at SR, opposite angle is 36. SR over sine 36 is equals to, I'm using this PR and 44. PR over sine 44. Now all we have to do is replace this PR over here and take 36 on the other side. So SR is equals to sine 36 over sine 44, and PR is 200 sine 65 over sine 35. So I'm just rearranging it, bringing 200 to left hand side into sine 65 and sine 36 divided by sine 35 into sine 44.
Sorry, could you repeat why we multiplied sine 36 over sine 44 with the other one?
Okay. This was sine 36. We took it on the other side, and that's going in the numerator, and this is its place.
Yes.
Sine 36 was being multiplied with PR, and this is PR. I copied PR from the previous question and just wrote sine 44 to left of it. That was already in denominator.
And then we
Should I
multiplied with PR.
Yes.
Okay, and then it gave us the answer.
I'll clarify. The sine 36, this was left hand side, and 1 over sine 44 into PR. I did this thing like in one step. So this goes over here, and then we replace the values of PR.
Okay. PR from the last question, and then that goes on top, and that goes on bottom.
Yes.
Okay.
Third number says, hence find the length of SR. So that's just use of machine. All values are there. So I'm plugging in the numbers. 200 times sine 65 times sine 36 divided by sine 35 times sine 44. And I'm getting 267.4. Approximately equal to 267 meters. Hence, evaluate area of triangle SPQ and PQR. SPQ and PQR. Okay. So I have SR, which is 267. So SPQ is in numerator. When I'm looking at SPQ over PQR. Let me just extract this in simplified form. This is SPQ and this is PQR. This is 267, that is 200. This full length is 467. Now, as you can see, these two triangles, green and blue,
Yes.
they're actually not similar, having different base but same height. So if I just say this is the height, I think we've done similarity and congruency.
Yeah, we have.
So this is straight away 467 over 200. 467 divided by 200. I'm not taking a square because this is not similar. So 2.335. As for explanation, if I just see HPQ, the larger one, that is going to be 1 by 2 into base is 467 into height, unknown height, this height, divided by the other triangle, that is 1 by 2 and base is 200, and we have a same height. So see, 1 by 2 cancels out and height cancels out. We are only left with base when the height is common. So it is,
If we added both the values together, oh, because they're different triangles,
yes,
the total,
because he was talking about SPQ. So this total was required 467.
yes. And then the 200 came from like RQ,
RQ.
right? Yeah,
Yes.
RQ. Why did we have to add the 200 afterwards when we have the total?
You can do it like in either way. I did that first and did the other part later. Like we needed SQ complete for
Yes.
SPQ. That is obviously 467 because SR was SR. Look at this third part right at the bottom. SR alone was 267.
Yes.
So SQ would be sum of these two. Are you getting confused for this 467?
No, I'm not. I'm getting confused for the 200.
That is already there for RQ.
No, I'm getting confused for why we had to add it into the equation after we had the total 467.
Oh, because he is asking about the ratio. SPQ is 467 and PQR is 200. We have two different triangles.
Oh,
Yeah, area of first divided by area of second.
oh, okay.
Yep.
Okay.
Okay, give a try to this question. Still doing it?
So 248.63 or 248.6.
That's correct.
So for me, I used the cos rule. For
That
you,
is
which one did you use?
same cos rule.
In cos rule, okay.
We cannot use sine. I don't have the other angle.
Okay.
Okay. B part says work out the area of the field. Area is equals to 1 by 2 generalized form A
Yeah.
B sine C 164 times 130 times sine 115.
9,661.2.
Correct. C part says the field is to be sown with grass seeds. Each square meter of field is sown with 3.25 grams of seed. The seed is only sold in 5 kg bags. So each square meter requires this much. 966 1.2 into 3.25. So we'll need this much. But these are grams. So if we divide by 1000, this is my requirement. So how many bags will I get? I'll divide this further with 5. So 966 1.2 into 3.25 divided by 5000. I'm getting 6.27. How many bags of grass seed must be bought? 7 must be bought. Any confusion why we wrote 7?
No, because we can't have 6, then we have a missing 27. 0.27.
Correct. In this case, we would have to round up.
Yes.
D part, a bird is hovering directly above B. The angle of elevation of the bird from A is 18.5. Calculate the height. The bird is hovering directly above B. So this is B, and that's the bird. And from A, the angle is 18.5. So in order to find this height, I need BA. BA is 130. See, the picture, the information is 3D, but I'm using the required data of 2D. So we use tan of 118. 18.5 is equals to height over 130.
So 43, yeah, 43.5.
Sorry, meters. 43.5 meters. Calculate the shortest distance from C to road X, Y. This is C, that's X, Y, and shortest distance is always perpendicular. I need to find this. So if that's 115, 180 minus 115 is 65. So I'm using sine 65 is equals to unknown over 164. Sine 65 is equals to unknown distance over 164. Any doubt in this?
Where is the 160? BC is 164.
Which is actually making a hypotenuse for this because this is 90 degrees. The shortest distance is always perpendicular.
Okay, no doubt.
So 164 times sine 65 is 148.6, approximately equal to 149 meters. Try this. I deliberately didn't share the entire sheet so you could focus on few questions. Should I
Mhm.
just share this all with you? I have many questions. I've made
Yes.
this a
Yeah.
scan copy,
Good.
and you'll also get these solutions along with them.
Yes.
So, okay, I'll share the complete thing. So
Okay. Thank
almost
you.
40 questions.
Okay.
Okay, so yeah, question 9. Because now you are at that position that you can also select questions for yourself and skip some for yourself.
Yeah, the ones I find hardest, I'll do them.
Sure. Still doing it?
Do you want me to answer all of them and then give you an answer, or do you want me to
Sure. Complete.
one by one? Okay.
Uh, okay, this one extra part when you get done with this. There are total 4 parts.
Okay. Okay, I'm done.
The fourth part, should I show you that?
Yes.
Hence, evaluate the area of SPQ and PQ. No. That's a repetition. That's page 8. Page 9. You've been doing this, and page 10. This is the fourth part.
Okay. Could you scroll up?
Yeah, sure.
Okay, thank you.
I'll zoom out if it is readable.
No, it's okay. It's not really that clear if you zoom out. But I already copied down like the main information of the question, so I just need the diagram.
Okay.
Sorry, it said that FE is parallel to CD and then also parallel to 40, which is below it. Do you know
F
where 40
is
is?
to CD, yes. And the last line, what did you say?
It's also parallel to 40 below it.
40 below it. Okay, on this sign FE is parallel to CD and is 40 centimeters below it. Yeah. So that's the
Oh,
vertical distance.
oh, so the height. Okay. Okay, thank you. Okay, I'm done.
Okay. So question number 9, I'm going to show you the answers. These are the 4 answers. A part 78.1. Is it so?
I got 44.3.
44.3. Okay, let's see. B part 127.
Yeah, I got 127.9 or
Very.
120. Yeah.
C part 24.2
Yes.
and D part 2900.
Yes.
Okay, only the first one, which is 78.1. Calculate AB. You can use cos directly. Cos of 35 is equals to base over hypotenuse. Now AB is equals to 64 over cos of 35. And one more thing, I'm getting 78.1. This could not be less than 64 because this is the hypotenuse of this triangle.
So it's the largest.
Yeah, it has to be larger.
Okay. So we use cos 35, and then it's going to be 78.1.
Yeah. What did you use?
Um,
38.1 square minus 64 squared whole square root. I'm getting 44. Maybe you found BC. That is 44.
oh, maybe.
Or you
Maybe
maybe
cos
you
as
use
well.
sine theta.
I think I did use sine because I can't find it right now, but I think I did use sine. That's why I got like a lower answer and BC. But
Okay.
it's supposed to be cos.
Yes. Okay, number 10. In triangle ABC, AC is equals to 14, BC is 8, ACB is 122. Show that AB. Okay, so that's going to be cross rule. AB squared is equals to 14 square plus 8 square minus 2 into 14 into 8 into cos of 122 and square root. I've just written it so many times that I'm writing it directly. Like, no need to do it directly. You can do in 2 steps or 3 steps as it eases you.
Okay.
So I'm getting 19.460. 19.460 approximately equal to 19.5 centimeters.
When we have already written like the equation and
Yeah,
we know the answer, like we're trying to prove that the answer is like
yeah,
a certain number, do we have to solve it or can we just show the equation?
yeah. We actually have to solve it because this is what tells the examiner that I've actually done it.
Oh, the extra decimals
Yeah,
before rounding it.
this is never going to be exact, 100% never. So you always write this answer first and then the one which we need to show. And
Okay.
one more thing, one may do it like this. Now I'm going to write it incorrect. Let's say I've written 14 square plus 8 square plus 2 into 14 into 8 by mistake. And I'm not doing it and I'm just writing that answer. So this is the mistake.
Oh, so even if we show the answer is correct,
Yeah,
but what we
he
did
won't,
is wrong.
he won't
Okay.
grade you full 4 mark. He may
Okay.
like award 3 marks, giving benefit of doubt that the student actually knows what he's doing. He's using cost rule, but he made a mistake of plus minus.
Okay.
Calculate A, B, C. So we've already done this. That's 19.5. And if someone fails to do A part, he can still do B part because the answer is given. So calculating angle ABC, sine of ABC over 19.5 is equals to, sorry, ABC over 14 is equals to sine 122 over 19.5. Sine ABC is equals to 14 sine 122 by 19.5, and ABC is equals to sine inverse of whatever we get in that, 14 sine 122 by 19.5. You can do it step by step. If you know your machine, you can do
Yes.
it directly.
37.5.
Just tapping in. I'm getting 37.5. Yes. Degrees. C part says a rhombus B D E C. B D E C. Okay, so that's something different. Of area 52 centimeters square and side 8 centimeters is placed next to triangle ABC as shown in the diagram. ABC as shown in the diagram. So we have BDEC. BDEC. So maybe it lies somewhere on this side. BDEC. And if that's a rhombus of side 8, we know rhombus as, like, I don't have page next to it, but we know that these all sides would be equal.
Yes.
All would be 8. And it says the area is 52. Given that BCE is obtuse, BCE, okay, that's obtuse. So I'm changing it. BCE is obtuse. It is this way. So all these are 8. BCE is obtuse. Area is 52. Now what does he need to know? Given BCE is obtuse, calculate reflex angle ACE. B D E C. B D E C. And we have to calculate ACE reflex. Reflex is more than 180. So before doing that, I need to know these angles. Now this area is 52, right? If I
Yep.
just split it into 2, I know the half is now 26. So 26 is equals to 1 by 2 into base into A into B into sine C. Now I can find this angle. 26 times 2 divided by 64 and shift sign of answer. I'm getting angle 54. Do not make this mistake. He's already made it clear that it is obtuse angle. So angle is 180 minus 54.3, which is 125.7. So if this is 125.7, what is this? A reflex angle, sum of these two. How the diagram is given?
Oh, below.
Uh, we did extra effort. So this is 122 plus 125.7. But I think we should take extra credit for this. 247.7. So,
So for you to get the angle,
yep.
so you use the area. Could
Yes,
you
because
show that again?
its sides were given.
Yep. So 26 is the area. And then we solved it through the side and the sine C. And then
Yep.
that's how we got sine C. Okay.
Yeah, we use this.
Okay.
The diagram shows a triangle PQR with PQR as 37. S is the point on QR such that PSR equals 90, PS is 8, SR is 5. Calculate PR. So for this PR, I'm using Pythagoras theorem.
Oh.
I cannot use sine cos tan. I don't have that angle, or I would have to find that angle first. and then do it.
Okay.
So I'm getting square root 89 approximately equal to 9.4.
9.4. Yep.
Okay, 9.4. The shortest distance from S to PQ. This is S. That's PQ. So I need to know this shortest distance. Hmm. It's 3 marks. Before doing this, I'm going to find, before finding this X, I'm going to find QS using the complete triangle PQS. This is 8. This is QS. This is 37. And I'm using 10. Tan of 37 is equals to 8 over QS. QS is equals to 8 over tan 37. QS is equals to 8 divided by 10, 37. And this is 10.61. Now, if this is 10.61, I can use this new triangle to find x. So I'm using sine of 37 is equals to perpendicular over hypotenuse. And I'm getting 10.61 into sine 37, 6.385. This is 6.4 centimeters. I just noted that time in PST that was 15 and I'm ended at 17. So this is 2 minutes. And in exam, you will get 7.5 minutes for this one question.
So in one section, there's how many questions?
Almost like 100 mark paper.
100 mark paper. Okay.
One
So
was around 80 and the other was 100. I'll check it and confirm.
okay. So we have like how much time to finish all of it?
That's again different. Because I'm just teaching 3 different boards, I don't memorize it. I've written it.
Yeah.
Okay, you'll be doing extended, that is P2 and P4. Yeah, total 200 marks. P2 is 70 marks and 1 hour 30 minutes. So almost 90 by 70 for each number, you're getting 1.2 marks. And
Yeah.
the other one is 130 for 60, 60, 120, and 30, 150.
So
And
130.
calculator would be allowed in both papers.
Okay. So 2 hours and 30 minutes for 130 questions. 130 marks.
Yeah, those are structured questions, long
Okay.
questions, and then short questions in P2.
Okay.
Okay, let's try this. The diagram shows a solid triangular prism. The dimensions are in meters. Calculate the volume of the prism. Can you do that?
Yes. Yeah, 505.
Good. Calculate the total surface area of the prism.
Okay.
Still doing total surface area?
I got 166 for some reason, so I'm trying to redo it. But
Should I do it with you?
yes,
Okay. First of all, there are 5 sides,
yes,
2 triangles, and both the triangles, the total is 21. Are we on same page?
yes. The area.
Now I have 3 rectangles, 7 into 10, 3 into 10, and the one at the bottom. That dotted line is actually, by Pythagoras theorem, 7 square plus 3 square whole square root.
The bottom dotted line?
Yeah,
Okay,
that would be square root 58.
okay.
Now we have these 3 rectangles, 3 into 10 plus 7 into 10 plus 10 square root 58 plus 21. And that's the total area.
Sorry, could you repeat?
Yeah, 3 into 10, the thin one on the left,
Yes.
then 7 into 10, the one at the top,
Yes. And
then
then
at the bottom, the dotted line is 10 square root 58 and plus 21 for the 2 triangles.
and then plus 21 for each of the triangles?
Yeah, 21 total. That like 10.5 is for one.
Okay. Which are the triangles? Okay, and then we get a total of 197.2.
Yeah, yeah.
Okay.
B part says the diagram shows the cross section of ramp A and the triangular prism B. The triangular prism B can move up and down the ramp A. The ramp is inclined at 25 degrees to the horizontal. When the prism is moving 2 meters up the ramp, it has risen h meters vertically. Calculate h. Oh, that's easy. Simply sine theta.
8.
925 is h by 2.
Okay.
So 0.85.
Yes. 0.85.
Second says as it moves up the uppermost face of the prism, prism B remains horizontal. The length of the horizontal edge of the face is 0.6. The length of the vertical edge of the prism is y. Calculate y. As it moves the uppermost face of the prism B remains horizontal. The length of the horizontal edge of the face is 0.6. The length of the vertical edge of the prism is y meters. Calculate y. So if I just suppose that it reaches this point, that's 0.6 and that's y. So basically these are two similar triangles. Just like this.
Oh.
So if that's a 0.6, this is y, this is h, and this horizontal is unknown. Where are the missing sides? This is 25. Maybe we'll be calculating this in terms of h, because y over h is equals to 0.6 over this unknown, which is like the base thing is like tan 25 is equals to x over h. So that's h tan 25. H tan 25. Yeah, done. So h cancelled. Yes. I did it by accident. By
So
tan.
0.6 over tan 25.
Yeah. So this is giving me 1.2867.
But how can, so we're trying to calculate the y on triangle B, right?
Yes. I did this. I'll repeat.
Yeah.
I did this 0.6
Yes.
divided by this, which was unknown for us. And secondly, y over h. So I'm writing that again. Y over h, similar triangles, is equals to 0.6. Then I had to choose what should I write. So I chose that this should be x and wrote in terms of h and 25. Used 10. 10 25 is equals to, this was h, sorry, h over x, and x is h divided by 10 25. So x is h divided by 10 25. Now we can cancel out this and find y. So this is 0.6 10 25.
So
That is
0.
0.279 or approximately equal to 0.28.
Okay. Okay, I see.
Okay, I'll share this sheet. This might take 2 to 3 minutes. We
Okay.
are having some sort of like internet issues on social media, I think. I think Google is working fine.
Yeah, no, it's okay.
Anything you would like to ask?
No, nothing.
I'll share this with you as it is, and you may skim and sign or do